I'm audible to all. Yeah. Okay. Great. So, first of all, welcome everyone to this webinar. I am Avinash Kaur, uh, and so let me give you a brief introduction about myself. Who am I? I work as a tech lead in a firm called CRM Next. I lead the AI and ML practice there. I have around 7 years of experience, out of which I spent 5 years experience in building machine learning products. So basically, I work in fintech domain where I generally implement banking use cases. And today we are going to cover basics of artificial intelligence and machine learning. And I hope after this session you will get some sense of how AI actually works. And one disclaimer, this session is about the introduction part. So, and machine learning and artificial intelligence is a broad field. So it would be difficult for you to, grasp everything at the first attempt of this webinar. It will take some time for you to, grasp that intuition and mathematical intuition of the field. So generally, it would take around, as an average, it would take around 6 months to a year to be an intermediary expert in the field. So you can take this session as a way to introduce yourself towards the field and check if you like it. Do you want to continue learning about machine learning and AI, or do you want to drop it and it's not your cup of tea and you want to move some other field of computer science, or the field, the domain of your expertise or domain of interest, right? So let's get started. I'll not going to waste much more time in introducing. So let me share my screen first. Give me a sec. Is it visible to everyone? If anyone, want to ask anything, just raise your hand. Once you raise your hand, and you can unmute yourself if you can, or Ritika can do that, and you can ask your question, or you can write your questions on the chat. I'll check chat and try to answer as much question as I can. Try to you know we'll do question answering session, maybe end of the session, end of one presentation, or maybe when I'll ask you to ask questions, so that I will not get interrupted in between, right? Second thing is, do you prefer language as English, or do you prefer Hindi, or do you prefer both? You can write on chat. You can go with that, or you prefer hybrid mode, both. Arushikandi, both English, Arish English. Okay, most of the people prefer English rather than both. Okay, so try to interact more in English rather than in Hindi. All right, so we'll go. Okay, so let's get started with introduction of machine learning. So let me give you a brief about the whole day, which the thing we are going to cover. So the first thing in this particular presentation, or this particular hour, we are going to cover about introduction to ML and DS. We are going to spend some 15 minutes in learning about supervised learning. What is supervised learning? We're going to go through about unsupervised learning, reinforcement learning, and we're going to learn we're going to scratch some surface for linear regression models also, right? So in first 2 hours, we're going to spend on these topics. After that, we are going to learn about the tools which is important to learn machine learning or to implement machine learning. So we'll move towards applied machine learning part. next after this session in next 2 hours. And in that part, what we're going to cover is we're going to cover about pandas, NumPy, Matplot. So we're going to do EDA, which is exploratory data analysis. And after that, we're going to run some use cases while doing EDA, data analysis. And then at the end of the session today, we're going to cover, at least we're going to cover one machine learning models, probably a supervised learning model. And we're going to run through a use case where we're going to implement supervised learning model and how to evaluate it, how to check if the model is good enough to put it in production or not, right? So before we move forward, some prerequisites I would like to mention here. That is, uh, you should know about Python. So if you do not know anything about coding, especially, then this session would not be much beneficial for you because everything. Second, you should know about Python and you should know about how to install Python, how to run a Jupyter notebook. If you do not know that, I'll share after this session, because in this session we are going to cover some theoretical part, just introduction part. After this session, we'll take some 15 to 20 minutes of break. In that break, I'll share some links which you can see and install Python and run Jupyter Notebook. All right. Right. So apart from that, there's no other prerequisites. I hope. Okay. Can you share? Can you tell me which year you are in your engineering, which branch you have? Just give me 4 or 5 responses so that I can check the demography of the audience. First IT, CS, third, mechanical, third EC. Okay. Okay. So we have mixed demographic today. So there are some people from IT, CS, EC, ME. Okay, great. So let's get started then, right? Let me start my presentation mode. Give me one more sec. Just give me 2 minutes. Okay. So, I mean, I hope you guys must have heard this Harvard Business Review that data scientist is the sexiest job of the 21st century. That's true in a sense where data scientists have to do a lot of creative work as compared to a lot of manual work and the redundant work which a normal software engineer normally do, because once you are able to create, let's say, a web app or an app, and you have to again create a new app, so you have to do the same things. Let's say you have to create a UI, you have to create a backend, you have to create an API which can connect these two things, and then you have to integrate with the database, and then your some basic web app will get started or completed, right? But this is not the case with data scientists, right? Because in data science, every time when you deal with a new data set, that is a new challenge for you. You're not going to, I mean, obviously there will be some basic first principle and frameworks which you're going to apply in all the use cases. But in data science, when you get a new data set, you have to start from scratch. Every time you have to start from scratch, and you have to learn new patterns in the data. You have to learn new correlations in the data. You have to learn about what actually data implicates, what kind of impact that data is making. Right? So, do you guys know what is when I say data? What is data? Let me clear some terminology in starting only, so that you'll not get confused in further sessions. Can you write what do you mean by when I say data? What do you understand by data? You can write on chat if you want. No? Set of information, correct? Information. Okay. What is the structure of data? Do you know what is the structure of data? When you deal, so many of you are from ECN, IT, CS background. So in what format do you store data in databases? Information is correct, Sign Sridhar. But in what format do you store data? Excel, bits, correct. So you store data in Excel, that's correct. But in databases, you normally store data in a tabular format, which is row column format, right? You have certain rows, and then you have certain columns, and then you have certain rows belonging to that column. So let's say you have data where you have information about a person, and that person, let's say, is Arushi, and Arushi is a name which goes into the name column, and Arushi have some age which goes into the age column. Arushi belong to let's say IT branch that goes to the department column, and these kind of structures. So there is a structure in the data. Most of the times there is a structure in the data. So that structure, so that kind of data is what data scientists get. Right? For instance, let's say you are dealing with let's say in your college you are dealing with the data, and you want to check the demography of your department, let's say IT department, and you want to check what other people belong to north of India, and what other people belong to south of India. What other people, how many males candidates are there, how many female candidates are there, what are the uh, uh, what are the percentage of 90% scorer in the male category than in the female category. So these kind of answers, if you have to ask, so if you have to ask, then you have to so you have to get this amount of data which is stored in your, maybe in your college website, or college database, right? So that kind of data a person will going to give you, then you're going to check these demography and then answer certain questions with that. Right? So that whole scenario is quite interesting, because normally, because data have lots of dimensions, right? And when you have lots of dimension, a normal human being is not able to answer that in small amount of time, right? So that when you deal with lots of dimension of data, at that time the data scientist job or data scientist skills come in, right? And that makes it sexy, right? So it's cool, right? And so there are lots of buzzwords that lots of data scientist jobs is going to pop up in 2018, 17, 18, 19. And that's true today also. We are sitting on 2021, and still the data science job market is growing exponentially. So before we dive into this domain, let's check the history of it, because we'll learn from history, and then we can predict future based on the history. That's what machine learning do, and that's what we are going to learn through this particular slide. So in 1946, it's all get started. One of the world's first computer created in 1947. Alan Turing processed the concept of AI, coined by Alan Turing, obviously. And then in 1950s, lots of people started developing prototypes of AI, in which some of, uh, uh, date people from Canada, US. I think there is a scientist who is AI researcher head in Facebook, Jan'21. I don't remember the exact name, but that is he was the first founding fathers of neural nets, which is deep learning. You must have heard of it. And Fukushima actually introduced the neural net, but these people have explored different architectures of neural net, and they got Nobel Prize for that also. So Turing Prize for that also, which is considered as a Nobel Prize. And in early 80s and 90s, AI second boom started, where people started acknowledging about knowledge representation through graphical representation of graphs and all. And in 2006, University of Toronto, which is kind of created a hub in 2006 for AI-based research. Lots of AI research papers was coming out of University of Toronto at that time, and the University of Toronto given lots of breakthrough in 2006. But the best flavor, or the tasteful flavor which AI got, which have given AI exponential growth, is in 2010, where machine learning and deep learning introduced, plus the computation power got increased exponentially. So earlier we were, I hope you guys must have remember, earlier we were dealing with 512 RAM of a computer or desktop, where we were excited about using that much power. But now, as you can see, we have 16 GB of RAM in our phone. So as you can see, that the computation have increased exponentially, and which actually benefits AI, because when you're dealing with lots of data, so AI needs to understand that amount of data, right? And once AI need to understand that amount of data, it have to use a lot of compute to converge the decision between the data, right? So once we break through toward the computing limitation, and we move ahead of it, AI becomes so good and so mainstream nowadays, so that everyone can use neural network models, train their model on their use cases, build new startups and all this stuff, right? They can do that. In 2017, Extract AI first deep learning powered parsing is launched, which is GBT. But lots of deep learning new models, deep architecture models, which is very complex in nature, introduced. Now it is quite easy for a person who do not have so much data or so much compute, but still can use these services through cloud-based services, maybe AWS or this kind of stuff, right? So I have coined lots of term right now, because it's just an introduction, like AWS. How many of you know what is AWS? You can write on chat. Amazon Web Services, Gotham, correct. Amazon Clouds, correct. Yeah, so some people of some of you know, right? So that's great. So AWS, correct. Amazon Web Services over cloud, correct. So these services provide you out of the box AI services, which you can consume directly if you do not want to indulge and create your own model. But obviously for that also you should know what exact services you should know, and how to judge that service. Is it working good? Is it solving my problem? Is it not? That kind of stuff, right? Okay, so let's move out from history, and let's discuss present. So can you tell me what is artificial intelligence according to you? Anyone? It is written on the slide. If you want, you can read it and then just explain the thing in your own words. What is AI according to you? So AI have different definition for different people. There is no one definition for AI. Some people feel that a simple chatbot, Alexa, or Google now is a AI. Some people feel it's not. Some people feel it's machine learning part or deep learning part. So imparting their intelligence or to models by training them so as to make our work efficient. That's true. So that's a broad definition of AI. But if you as you can see in the diagram, AI is quite vast, and machine learning and deep learning comes under this umbrella, right? AI as of now is doing any job that humans can do in seconds. Okay, so Gautam, it's not the speed which AI brings in, right? It's the intelligence part which AI brings in, uh, because a computer can do, much faster. Quantum computing can do much faster what human can do right now. But the main factor which differentiate is the intelligence part, right? So making capable of mechanic machine to think and perform like human brains. That's true. That's true, Dia. So, what according to me, so let me give you my definition, what I feel AI is. According to me, what Dia has, most, nearest definition of AI. That is, if your machine can act or comparably act as a human creative person, right? So why I use this word creative is because a repetitive work can a robot do, right? A normal robot, if you go in the factory, maybe in Tesla factory, you can see so lots of repetitive work a robot can easily do, right? But there you do not need a creativity in that, right? So you need a creativity in a place where you do not have certain knowledge of that particular scenario in past, but still you are able to create something. You are able to solve that problem or create something new out of your experience, but not exactly your experience with that particular problem, right? So maybe if you want to create a new symphony, you AI cannot do that. AI can create nowadays. You can see generative models. Again, I'm coining a new term. We'll learn that eventually in a session. So right now, we have models like generative models, right? Who is able to generate new images, which normal human, I mean, these human do not actually alive, but still AI is able to capable of generating a new image, or maybe generating a new, lyrics, or maybe new tune, you know. But is AI actually making any creative effort or any concise decision in creating that particular lyrics? I feel no. So how generative models works is actually they just have some bits and pieces from all the lyrics it have learned, or the person have provided in training. It fetch some bits and pieces and combine it in a way that you feel that it's a new symphony, or lyrics, or something like that, right? But when when AI can act as creative as humans, which I called as artificial general intelligence (AGI). So when AI is capable enough to become AGI, then I feel we'll achieve artificial intelligence, or artificial general intelligence. That's AI for me. But till now, till we are not able to achieve that, I am good with machine learning and deep learning. I'm happy with that. And so that's a definition, that's a whole definition of AI according to me. Can anyone tell me what is machine learning and deep learning in chat? Anyone? No? Okay, so as I've explained about AI, artificial intelligence. So machine learning is subset of AI, as you can see on the slide. Uh, but for machine learning to make a model which can predict something, you need a lot of manual work, right? You need to handle your data. You need to check which exact feature. When I say feature, it's column in your database. So which exact feature is important, which exact data or dimension is important, and according to that you filter. Anish, is ML is training a model as per given data scenario, which helps it predict what course of action to take in future. Exactly, Manish. Exactly, Anish. So you're going to provide some data, but you have to handle that data manually in certain way. You have to understand a pattern in that data first, and then according to that you're going to choose which exact model you're supposed to run on machine learning, and then again you have to evaluate your model. If your model is good enough with certain evaluation metrics, we're going to learn about that, and then you're going to deploy a model so that other people can use a model or get prediction from it, right? So that kind of manual work involved in machine learning, which is not supposed to be in the AI, in AGI or AI, right? And what do you understand by deep learning then? Exactly, Gautam, you're correct. That's what ML do. So what do you understand by deep learning? Anyone? No? You can write or you can write. I'll start explaining about deep learning. We have learned about AI, we have learned about ML. Now, the part which is manual in machine learning, and the part is the thing is machine learning gets difficult if you have lots of dimensions, right? Okay, so deep learning is developing artificial neural network, according to Gautam, to predict output. So deep learning is not developing artificial neural network. So deep artificial neural network is the smallest unit of DL. So it's the basic architecture of deep learning. Gautam. DL applying various models to train. Okay, so Harish have taken the simplest path to say that applying various model to train is deep learning. So Harish, on the higher level, it's true, but it's true for AI, ML, and DL for all these things, right? So, what deep learning actually is, the manual part which you were doing in machine learning. So, cleaning your data, handling features, what are the important features, what are not, removing that unimportant features, using only important features. All these stuff which you are doing manually in machine learning, you do not have to do it in deep learning, right? So most of this manual work will be handled by deep learning. So the first thing is the important feature extraction, right, which you do, or the feature engineering, which you do in machine learning. We'll learn about that. So feature engineering, so I'll give you a brief. So feature engineering is nothing but when you have 10 features. When I say features, that is column. Let's say you have salary, you have age, you have address, you have geography, that long, something like that, your data. And you feel that out of these features, some features are not important and some features are important, so you're going to extract those features which are important. And if you feel that, if you let's say uh, if you multiply age with salary, then you will get a new feature, age, product of age and salary, and then you can create a new feature. And if you feel that new feature actually impact your machine learning model to learn better in a positive way, then your product of age and salary will be a new feature, and you can remove your age and salary and then just use one feature. So that's a basic definition of feature engineering, how you create new features. So that kind of stuff you do not have to do with deep learning, right? With deep learning, you just have to prepare your data in a way that deep learning accepts. We call it tensor, which is n-dimensional array, right? And then you consume that. So your neural net architecture, whatever architecture you use, let's say ANN in this case, artificial neural network, is going to consume that data in a tensor format and then train according to the architecture, right? Whatever architecture you use, and then give you some prediction. So in deep learning, you have multiple layers of training, but in machine learning, you have just single layer of training, right? Just single layer of training. So and that's why it's called deep. That's why it's called deep, because in first layer you may be focusing on some important features. In second layer you may be focusing on other important features. So you do not have to exactly do feature engineering in deep learning, right? The second part, so this one problem which deep learning solves, and the second part is uh, if you if you're dealing with a data where lots of dimensions are there. So we have, let's say, 200 columns, 300 columns of data. So if you have 4 columns of data, it will be easy for you. Even a human can, understand that what this column is. So if age is above 20, the person may be in college, or may not be earning, and these kind of decision you can make if you have just 4 columns, right? But if you have, if you have a lot of column, let's say 200 columns, then it will be difficult for a human being and for machine learning models also to converge better, right? To make better decision, because lots of variants are there, lots of columns are there, and it get confused. But if you have deep learning model which have lots of layers to learn, so a group can learn more as compared to individual. A group can focus on. You must have while doing group study for your engineering, maybe in whatever year you are, when you prepare for your semester. So the lazy people like me, what they do, they study in group. They give, let's say you have 5 chapters to complete, 5 lessons to complete. You give one lesson to each one of you, and then each one of you complete that lesson in 2 hours, and then just exchange those lessons in next one or 2 hours, right, with each other, right? So that's a group study which you do. So think deep learning as a group learner, right, and machine learning as a single learner, right? So that's why deep learning can focus on more features, more lessons, if I can say, more lessons in a smaller amount of time, and can converge better as compared to machine learning, right? So these two differentiators are there. So let's check out. So this is the basic. I've already explained this. So the traditional programming paradigm, how it works is, I think someone have written that in the chat also. So you normally provide some input according to your. So you are a software engineer. You're going to about a certain algorithm, right? And you're going to write that a program to solve a problem, a certain problem, right? And then your computer will run it and give you an output, right? So. But in machine learning, that's not the case. The machine learning, you're going to provide input, and then you're going to provide the output also, right? And the machine learning will give you the program part, right? The machine learning will give you the program part, this part, right? So you're going to provide this, you're going to provide this, and you do not have to worry about the logic, the algorithm. The machine learning will going to create the algorithm for you, right? So it will going to find out which are the important parts, which are not, and then based on that, it is going to create an algorithm which you can use, to predict further. And so anyone have any question till now? Then we'll move forward. You can write that question on chat. Anyone? No? Okay. So, what are the application of machine learning, right? So that's a thing where you all have experience. You have your own experience with machine learning. You must have used a lot of product nowadays in the form of app, in the form of some hardware device in your day-to-day life, and you must be experiencing uh, that this particular device or app actually helps you or optimize your work, or ease your life, right? So what are your experiences? You can write on chat. Till then I'll explain the application which is written in the slide. So what actually fascinates you? What AI use case solves your problem on a larger scale in your day-to-day life? You can write on the chat. So there are lots of application of machine learning. So I'll start with recommendation engine because lots of you must have know about Netflix, Amazon, Prime Videos, right? So you must have go and check your favorite movie. Maybe you like thriller movies. The genre of the movies could be thriller, and you feel that this is for the particular movie, but maybe you do not want to watch all thriller movies again and again, right? But still, if you go and watch a thriller movie in Netflix, the Netflix is again going to recommend you a same amount of thriller movie because Netflix feel that if you watch one thriller movie, that means your taste in thriller movies is good. Right? So I mean, you like thriller movies more. So that's how Netflix recommend your so predict or recommend movies for you. So we call it in recommendation system language, we call it collaborative filtering. And Absolutely. So okay, so for Ainesh Advani, recommendation model, general YouTube, Netflix, Spotify helps him a lot. I mean, that's a most impactful AI service which he's using. So similarly, for filtering algorithm like newsfeed, for Google Ads, maybe you want to buy a laptop, right? And you're searching on Google that about laptop or features of laptop. The Google will going to give you ads related to that. So uh, once you hit on that particular ad, that Google feel that you get converted, right? So that means their recommendation system is actually working. So that's improved their recommendation with period of time based on your profile. Filtering spam emails, Gotham, correct. So filtering spam emails is a good use case where lots of spam where they say you won $1 million lottery. Give us your details and we'll give you $1 million, which never comes. So these spam emails help us to filter these kind of emails and go into the spam folder, which is a classic example of classification. So text classification specifically, in which you classify a certain email or the structure of email based on the content of it, and then you classify that is it a spam or is it not spam. We are going to take that example further in this slide uh, as intuition to create machine learning models, right? So facial recognition is as nowadays you can see you have mobile phones in which they provide you facial recognition app where you do not have to type your pin or create your pattern. You just need to show your face and it gets right. So and one the most important, which I personally feel the most important application and going to solve a lot of problem in next 5 to 10 years is going to be autonomous vehicle. This part, autonomous vehicle. Have you guys heard about Tesla? Anyone know about what is Tesla? You can write on chat yes, or I'll explain what is Tesla first. Yes. Okay. Okay. So yes, most of you I think know about Tesla, and so Elon Musk always create news, so it's easy to people know about Tesla, right? So Tesla is one of the key players in autonomous vehicle, but the important thing which they're solving is electric vehicle EV, and but I think the cool part about Tesla is they are also creating autonomous vehicle. So I dream about a world where people do not drive their own car, especially if you are in NCR. Right? There are lots of rash drivers, and people do not drive their own car. Autonomous vehicle can drive it. You own a car, but you are not allowed to drive it because normally people break rules. They more prone towards accident. So, but if you're dealing with autonomous vehicle, the autonomous vehicle will go with the with the rules. They're not going to break any signals. They go with the speed limit, and it's much safer. So if all the cars in the street is autonomous, and then we will be living in much safer place as compared to today. So that's my dream. If Because the second thing is I do not like to drive. So that's also a bias towards my dream, right? So yeah. Anyone have any question on this? Any different application you feel is important? You can discuss that. You can put it in chat. Anyone? Okay. So let's move forward. So this is again different kind of, because I work in bank, so I put a bank slide where lots of bank based use cases, which is upselling, cross selling, price life, predicting lifetime value of customer is one use case where actually bank gives you offer. So I mean, you most of you are in college right now. You may not have a good CIBIL score or credit cards or not, maybe. But the people who have, though, how bank actually calculates is, and how bank actually gives them offer is, they they run a ML algo to check their lifetime value of the customer. So if they feel that customer have this year have 5 lakh rupees to spend on us or on banking products, so they are going to pitch them to get all these 5 lakh rupees into their bank account. So not exactly bank account, or to pitch them the product which value 5 lakh rupees through whole year, right? So that they can convert that leads into a product and get that money, right? So that's how bank actually evaluate and give you offers. So apart from that, there's social media where you have different. So they're going to recommend you different people. Let's say if you're using Facebook, you can see that people you may know is one of the feature which ML provides uh, based on the interaction with the network. So this particular ML algorithm comes into the graphical network analysis domain. Right? So and apart from there, lots of automation, trade insurance, and healthcare. So healthcare is one important thing where ML can create a big impact, or AI can create a big impact. So I think there's a startup named Cure, QURI, QURE.ai. So which is trying to solve or optimize the process of finding cancer, chest cancer specifically, where lung cancer specifically, where when you go for an X-ray, the person is going to take around 2 days to get create an X-ray, then write a report on the X-ray, and then give you the report, right? But that algorithm with the startup is building, that can do this whole 2 day stuff in just 15 minutes. So you just need to scan and your chest, and in 15 minutes they're going to give you accuracy. They're going to give you the report with an accuracy of around, I think the last accuracy they have mentioned is 87%, right? Which is equivalent to the lab person's accuracy, right? Most of the time, or sometimes it's better than the lab person accuracy. Right? So that kind of problem AI is solving nowadays, right? So we have learned about the application till now. After this, we are going to jump on and create an intuition, right? So we have learned about what are the use cases of AI, what is AI, what is machine learning. Now let's learn how actually AI or machine learning works, right? Just an intuition part, not the technical part, just an intuition part, how it actually works. So let's say you have a recommendation service to download app. You are supposed to create a recommendation service to download app. Right? You have this. So what I was talking about earlier, this is the data. Right? You have column gender, you have age, column age, you have column app. Right? And this is the data inside the column. you have gender, which is female, you have age 15, and that person have downloaded the app, which is Pokemon Go, right? This is Pokemon Go. I don't think I should explain this. You must have know already. This is WhatsApp, this is Snapchat, right? Popular apps in the main group. So now what the question here is between gender and age. So you understand the use case right now? What is the use case? So you have these two columns and you're supposed to predict the app. So if the gender is female, age is 15, the person downloaded Pokemon Go. If the gender is female, the age is 25, the person have downloaded WhatsApp. Right? So you are supposed to, I'm going to give you these two columns, and you are supposed to predict these two, right? Without any machine learning or AI. Right? So what do you think? Which one is out of gender and age, which one is more decisive to predict the app download? You can write on chat. Age, okay. Abhinav, age, okay. Anyone feels gender? No? No one feels gender? Okay. So let's check out what is so let's check out first. Let's deal with gender part. So in the gender, as you can see, we have female who have downloaded Pokemon Go. We have female who have downloaded WhatsApp. We have male who have downloaded Snapchat. Then female WhatsApp, male Pokemon, male Pokemon. Right. So this is you can see that only one male with Snapchat. You can maybe take decision that male is going to download Snapchat, not female, because there is no female who have downloaded Snapchat in this data set. But it is difficult to differentiate between female uh, when you are supposed to make decision based on Pokemon Go and WhatsApp, right? So let's check out the age part. So let's check out the age. So in age, if it is 15-year-old, the person have downloaded Pokemon Go. 25 WhatsApp, 32 Snapchat, 40 WhatsApp, 12 Snapchat, Pokemon Go, 14 Pokemon Go. Now, what do you think? What would be the decision boundary if you have to, let's say, create a filter between uh, Pokemon Go and other apps? What would be the decision boundary for that? Let me know if you're not able to understand what I'm saying. So I'll repeat my question. Anyone? So if you just have to put a filter that age greater than this is going to download Pokemon Go, age absolute correct. So age below 15 by Sudarshan and Deepak is going to download Pokemon Go, and age above 15 is going to download WhatsApp and Snapchat. Absolutely correct. Now you have created a decision for age. Cool, right? Now you have to create a decision for between WhatsApp and Snapchat. Can you do that? Of age? No, right, Sudarshan? Okay, you cannot do that. Then what we can do? What other features we have? So Aditya feels if male Snapchat. So male Snapchat. So that means Aditya, you are going to consider this feature now, right? The gender feature. Okay? And then firstly we have filtered based on age. Then we are going to filter based on gender. And then yes, if he is female, yeah, correct. So age is correct, right? At first. Now, how it is going to create a decision tree? As you can see, so we have taken some offset value so that it will not be hard 15. So we have taken 20 as offset value. So if age is less than 20, it is going to download Pokemon Go. If age is greater than 20, then it will go and take decision based on gender. Right? If gender is male, it is going to download Snapchat. If gender is female, it is going to download WhatsApp. Right? Easy, right? So this particular algorithm which we just learned is called decision tree algorithm. There's a simplest intuitive algorithm which normal human being can understand, visualize, right? And this is what, so in normal programming scenarios also, if what you do, uh, you do not create algorithm from data. You just know that before, if age is less than this, then recommend this. If gender is less than, if gender is female, recommend this, right? So but this if and else which you normally use in programming, if this if and else is created through data rather than through your own knowledge, right? So that's a decision tree, right? Do you have any question on this, anyone? Okay, Deepak. Okay, let's move forward. uh, so do you feel that decision tree is quite easy? Machine learning is quite easy now? No rocket science? Okay, awesome. So let's take a different use case now. So we have learned about decision tree in last use case. Let's take the spam no spam use case. Someone have mentioned that in the application part also. Right? So these are the mails. These are the mails which is considered as spam, right? And these are the these are the mails which is considered non-spam. These are the mails which is considered as spam. Right? Now let's see what are the differentiator between spam and non-spam. So let's say we have a word in our mail which is cheap, right? And with some fancy GIF in that, and lots of colors in the mail. Right? So generally, these kind of mails are spam mails. Right? So if you have, let's take some small example which is cheap. If you have word cheap in your mail, then let's check in which amount of mail you have cheap. So in non-spam mail you have cheap in 5 mails, right? And spam mails you have cheap in around, I think, uh, 40 it is, 20 it is, right? 20, right? Okay, so in 20 mails, right? So as you can see, the 80% of this spam, 80% of this spam mails have cheap keyword in it. Right? What that indicates, I mean, if let's forget about the ML algorithm. If you are a person who is going to, if I give you this particular information that cheap is 80% present in spam mail and just 10% present in, or 5% present in non-spam mails, then how, what kind of decision you're going to make? So if you have next mail with you and you find cheap in it, right? Then what you're going to do? You're going to consider it as spam or non-spam. It's an easy one. Cheap is the word commonly found in spam. Correct. So you're going to consider that mail as spam. Correct. Okay. So if you have to deal with this, I think I've already given the answer of it. Can you tell me, if an email contains the word cheap, what is the probability of it being spam according to your data? 80%. Absolutely correct. Right. So that's and when you deal with probability, right? When you deal with probability, then you do you know what is bias naive Bayes. You know what is Bayes theorem? Anyone? Yes, can you write Raghuvansh Singh? So spelling mistakes. So I'm just giving you some different example. Like if they're cheap, then 80% of it, 80% chances that the mail is spam. If let's say you have lots of spelling mistakes, right? And then 70% chances that it's a spam because normally people, do proofreading before they send mail. So that's why the chance of having a spelling mistake is less. And nowadays, Gmail is also supporting you to check the spellings. So it's so if you have spelling mistake, lots of spelling mistakes, your mail the 70% chances. So I'm just giving you 70% based on the data. It can go up and down based on the whatever data you have, right? So if the person is not providing you title, the 95% of chances that it's spam. Right? So that's how this probability is getting calculated, and the algorithm which I was explaining earlier is called naive Bayes algorithm. So naive Bayes algorithm comes in the paradigm of probabilistic machine learning, right, or probabilistic algorithms, where you deal with probability rather than decision tree. As you remember earlier, we were dealing with decision tree, if and else, greater than, less than, and all. So, but right now we are dealing with probability, which is based on the occurrence of an event, right? Right. So, occurrence of an event based on the sample data which we have, right? So we have covered two different flavor of machine learning: naive Bayes algorithm, decision tree algorithm. So let's learn about the different category of machine learning. So we have supervised category, in which we have regression, in which we have subcategory called linear and polynomial. What is regression? Regression is something. Let's say you want to predict about score of India, right? So right now the test match is going on between India and Australia. So let's say you want to predict based on the first session, you want to predict the score of India in next three sessions. Right? So if you want to do that, so that kind of thing comes into regression models, where you are going to predict next value, right? Next incremental value. Or if you guys must going to prepare for interviews, and you must be going through your aptitude revision, and in which you must have done some next numeric value based on the pattern, so that kind of thing is linear or polynomial regression, where you're going to give next numeric value, like continuous value. Then decision tree we have covered just now. Random forest is a flavor of decision tree, where you in decision tree you have one trees. In random forest you have multiple trees, and one tree give knowledge to other tree. Then other tree learn more on top of it. Then third tree learn more on top of it, and then give you final output. The third flavor of supervised learning is classification. In classification, you have KNN, which is K nearest neighbor. You have trees, which is again the distant trees and random forest. You have logistic regression, which is a flavor of linear regression, but it's a classification model. So what is classification? Classification is just now which we have done is, let's say if you're doing, um, if you're supposed to classify a text, right? If it is positive text or negative text. This is the simplest example you can find on internet right now. If you are supposed to predict that is it a positive text or a negative text, it's a classification, right? It's a text classification problem where you classify the data in one category, and based on the differentiator between these two categories. Right? So naive Bayes again a classification issue, but the differentiator is the naive Bayes works on probability rather than tree based or logic based, right? And SVM is support vector machine is again a type of classification, but it works on the geometrical decision boundaries creation, right? It just segregates between two classes and try to find out the differentiator or the maximum differences between two classes. When I say classes, that is positive and negative are the classes which we mentioned, right? And the second category is unsupervised learning. In unsupervised learning, we have SPD, we have PCA, we have K-means. So the most commonly used algorithm for clustering is K-means, which is in unsupervised learning, you do not have to provide any prediction values. As you have learned that we have spam and non-spam, we have spam as one prediction value, non-spam as second prediction value. But in clustering, you do not have to do that. You just need to provide some. You just need to provide your mails to this algorithm, and your algorithm will going to create different clusters based on the similarities in that cluster, right, within the cluster. So if there are two different mails, then probably it is going to create two clusters, one cluster for spam, one cluster for non-spam. But you do not have a specific out-of-the-box name for it. Principal component analysis, which is PCA, again a complex algorithm which actually were used to reduce the dimensionality, right? And you do not have to provide specific classes to it. And similarly for singular vector decomposition, which is SVD, XVD, for SVD also you do not have to provide. So it's a flavor of PCA, which is again a dimensionality reduction algorithm, right? So these two are complex algorithm, but we can focus on K-means for now. Then similarly in unsupervised learning, we have association analysis, a priori and FP growth. A priori is something which, if you go in supermarket, they are going to, so they create their placing of product in a way where they feel that if you go, let's say, if you go and buy milk for your child, maybe you need a diaper, a pack of diaper for the person. So you can see that kind of placing of product where you will have baby products at one side and milk at one side. Right? So what they feel is these two products go in same basket. Right? That's, we call it basket analysis in different terminology. So these two products go in same baskets, right? So when a person buy one product, there are high probability that person can buy other product also because they have similar needs. So that kind of association analysis we can do. Then we have hidden Markov chains, which is nothing but the graphical representation of one of decision making from one point to other point based on the events happen on a particular node. Then after that, we are going to we have reinforcement learning. So reinforcement learning is where you do not need any out of the box data, any unsupervised data, any supervised data. You just need an environment and you just need an agent. We're going to look about reinforcement learning in detail. So I've already explained about supervised learning in brief. So let's see it visually. So in supervised learning, the first step is you're going to have some data, which is, let's say this is image classification problem, in which you are providing lots of images like cats, right? Different kind of cats you have, and then you are going to feed that data to your machine learning models, right? And then you have so you have different, and second kind of data you have non-cat, not cats, or it can be anything, or it can be dogs also, right? So your machine learning model ultimately what it do is it is going to predict that if the new image which you're going to feed these images, is it cat or is it not cat, right? Is it cat or is it not cat, based on the thing which we have learned about naive Bayes and dysentery part of thing, right? So because this is image based thing, earlier if you guys remember we have learned about structured data, which is gender and age, but this is you cannot find that structured data in image, right? What is the smallest value of image, anyone? What is the smallest value of image? You can write on chat. What is image consist of? So many of you must have learned about pixels. Absolutely pixels. Sridhar, science either. And what is the range of pixels? 255. So range start from min and max, which is 0 to 255. Right? Okay. So obviously you can see that you cannot have normal data out of images. So you're going to deal with pixels through this, and through pixels you're going to find out certain features on images. Based on that, you can differentiate that if the features is if the edges like this in this particular image, it is more tend towards cat, and if the edges like this in the image is more towards like not cat or dog, right? So that kind of decision you can do. So we generally deal with image classification in the deep learning part, where we have architecture like CNN, which is very helpful in getting these kind of feature maps. Okay, so this is classification problem, and similarly we have regression problem. I already explained that if you want to predict next, so you have data till this point, and you want to predict this. What would be the next data, uh, next prediction of output? Then you can use a regression model, linear regression, polynomial regression to do that. Okay, so when I say so, in next 4 hours, when I say decision tree, this is decision tree which I am referring to, right? With decision tree, sorry, when I say decision boundary, this is decision boundary which I am referring to, which means that you have one class here, which is, let's say this is cat, right? And one class here which is non-cat, not cat, and this is the distance between these two classes, right? So this is the decision boundary which will differentiate between cats and non-cat. And this is classification, classic classification problem. This is regression, right? Now, how unsupervised learning works. So one important thing which I've already explained, and I'm just repeating it again, which is for supervised learning problem, you need a label, right? You can see that, right? You need a label. But for unsupervised learning, you do not need a label. You do not have a label to do that. Uh, if you do not have label, then you can use unsupervised learning, right? So you have raw data, raw input data, which do not have any labels, which do not go in any category, and then you feed that into the interpretation, and through you're going to feed that into your learning algorithm. So in this case, let's say we have k-mean clustering algorithm, which ultimately going to process it and give you the output, right? So what it is do, it is going to try to find out the distance between the data, this data and this data, and see if this data belongs to one cluster because all the similar features it have, and this data belong to second cluster, and this data belong to third cluster. So that means they have created 3 clusters, and are based on the features it have, right? The similar features it have. So in k-mean clustering, so we are going to cover about k-mean clustering in details in further sessions, but just to give you a brief, that k-mean clustering, when you say k-means, that means k is equivalent to the number of clusters you are supposed to create out of the data. And in this case, the k will be 3 because we have created 3 clusters. Right? And why it called mean? Because it is we are going to you know uh, deal with the mean of the distance, right? When you have distance from one point to other point between the data, so we are going to deal with the mean of the distance between these 2 points, and then going to create cluster around that, right? So that's why we call it mean. Okay, it looks similar to this. We have already explained. Now, uh, the very exciting algorithm and a complex one also, which is reinforcement learning. So in reinforcement learning, you do not have to explicitly provide data or supervised data or unsupervised data, labeled data, non-labeled data. You actually have to provide an environment where the agent will go and explore that decision by itself, and how you're going to um, punish that agent is through rewards. Is through rewards, right? So, uh, so let's see how it works, right? So you have an agent in your environment. Let's say you are supposed to uh, train an agent, a model, to play a certain game, right? Um, I'll I'll take a simple game, let's say NFS, right? So uh, or Mario. Mario is a simple game. So let's say you are supposed to you have environment of Mario, and you have an agent which is again named Mario, and you are supposed to get highest score through an agent, and you want that agent to learn how to get a high score, right? So the agent will go to the environment. Agent will take one decision in one particular state. This is state. State means the agent will move one step, left, right, up, down, whatever it is, right? Based on that. And then based on that, you are supposed to, if through that state, whatever the decision agent is making that state, if the score goes up, or then you're going to give reward plus one. Right? If the score goes down, if you feel that, if the environment feels that you have taken a wrong decision, the agent have taken a wrong decision, the reward will go down, right? T minus whatever. So not T R T minus one, certain amount of reward it will give. The T plus one and T minus one is the time based state. Right? So the reward will be positive or negative based on the decision. Right? Then it is going to feed to agent on based on that. If agent feel that okay, I with the last step T step, I have received a negative reward. That means I made a mistake. I should check the other state in T plus one, and then check if I'm getting a positive reward. There is a simple intuition about reinforcement learning. As you can see, let's take an example of this. The dinosaur is supposed to go here. It is going to move forward. It's wrong. It is going to get negative state, negative reward. It is going to go up, going to get positive reward. Then it is going to go right. Then it is going to get positive reward, and based on that, it is going to make decision that where it should go to reach this place. Right? Okay. So similarly, I've already given the example of Mario, which is an agent, and this is the environment, which this will learn that how to get maximum reward. Okay. Till then, anyone have any question? Anyone? No. So are you guys able to follow what I'm trying to explain, or is it getting difficult, confusing? Let me know any point of time if you feel that it is getting confused, you're getting confused, not able to understand. Right? I'll try my best to revert that. Next action is taken by considering state and reward. Yes. Sudarshan BS. Yes, Sudarshan BS. So next state you're going to take based on the next state you're going to take based on the reward you're getting. Yes, correct. The Deepak Swalka. Yes, the next action is suppose. So let's take this example. This is the action part, right? It is going to go up, right, left, and all. And when it takes action 80, it is going to change the state, right? The state it is in. So it is at first action is going to be in this state. The next action it is going to take right up. The state will change, right? And it's going to receive the reward in this particular state. Okay. Okay, so let's move forward then. Okay, Sudarshan. So now slowly it is going to get difficult in next further sessions. The reason behind that is obviously it feels like the machine learning is relatively easy, but there are lots of things which you're supposed to consider while building a model, and lots of skills goes into doing data analysis. That's why it will get little bit boring after this session. Please bear with that, because it's a hurdle which you're going to get in any part of learning, where you're going to hit a stone and then you have to jump on top of it to move to next level, right? So the first thing, okay, how many of you know about Python, pandas, NumPy before coming to this session? You already have some basic experience with that. Arushi, Gandhi have, Harish have, okay. Only Python, Sudarshan have. Okay, so lots of people have Python experience. That's good. That's good for me. And some people have experience with, I believe, with pandas. That's also good, because it will be much more easier for you, to understand what I'm when we go through the case study. And okay, so that's cool. Okay, so machine learning pipeline. So now machine learning pipeline is something which you're going to build. Let's say when you go in industry, you're going to build your machine learning pipeline from start to end, right? When I say end, that means the deploy and predict part, this part. When I say start, that means prepare data, right? This part. So as I explained, that you are supposed to store your data somewhere, right? So let's take a use case to understand this. Let's say you have a client for let's say uh, there is a restaurant, right? So there is a restaurant where the restaurant owner asks you to create a predictive model, which uh, in which you're supposed to predict that which customer, which cuisine you should predict or recommend to which customer, right? Just a simple use case, I think, right? So if you're going to deal with that use case, so the first thing you're going to ask to that restaurant owner to give the data of the customers, the historical data of the customers, based on, so for to accomplish something like that, the restaurant owner should have some personal information regarding their customer, right? So the customer name, maybe the name is not that important, maybe it is, based on you can, based on name you can find out the geographical origin of the person, and maybe the taste of the person, maybe someone from south, like uh, dosa and idli more as compared to north, someone from north, or like aloo ka paratha more, right? So that kind of basic thing you can do, geographical feature. But apart from that, what kind of, how much spend that person did in the restaurant, right? Have that person spend $1,000 on the restaurant, where a normal average spend of a customer in the restaurant is $500, right? So, and if the person spent $1,000 in the restaurant, or maybe the person is doing it from last 6 months, come every second weekend and spend $1,000, and if the customer is high value customer, and you can recommend exclusive cuisine to that customer, which the customer can buy, right? So that kind of knowledge you should have about your customer. So to do that, what you're going to do, you're going to ask first the data, right? This is the data. So you're going to ask that data to the restaurant, give me the data of customer with a label of that, what customer bought, what kind of cuisine customer bought, how much spend that customer had, right? Once you get that data, now the data is not clean. The data is very cruel, right? The reason behind that is lots of software engineers, because I was one of them some years back. So I am, so I do that mistake. So lots of software engineers do not actually consider analytics while designing their backend. So lots of IT people or CS people, or maybe some EC people, can also understand what I'm trying to say. So when you create your backend, when I say backend, that means your databases, your backend APIs and all. So when you create your backend, you do not actually think about data cleaning or what kind of format your data should be in. Maybe some people just, you have a JSON, maybe some people just dump that JSON in one particular column. Right? Maybe you have data type columns and you just dump that data type columns, date type columns, and you just dump that date type columns, maybe in a string format because you feel that no one is going to use it. It is just a read only view. So that's why. Maybe many people just, rather than putting null into databases in numeric value, they put zero, or they put just lots of null rather than default values. So that kind of data mismanagement happens from a software end, and that becomes a nightmare for a data scientist most of the time. Right? So maybe you're going to, I mean, when you pass out from your college and you get a job in machine learning, maybe you get a designation of machine learning engineer or data scientist, but and and people around you or friends of you must be thinking that you must be creating a state of the art models, but let me give you a reality that 90% of your time you're going to spend in cleaning the data, preparing the data, creating the features, right? And just 10% of your time you're going to spend in training a model and evaluating a model and deploying it, right? And most of the time you're not going to deploy it, someone else is going to do that for you. So 90% of the data, 90% of your time you're going to spend in this particular part, prepare data, right? It is supposed to be bigger than these two, right? So this particular part consists of normalization of your data, transformation of your data, validation of your data, featureization of it. Right? So let's understand normalization of data first. One by one, let's go through this. So normalization of your data means, let's say if you have data which, so if you have lots of columns, one column is salary, one column is age, right? Salary can go from 10,000 to 10 lakh per month, right? But your age range is between, let's say, 20 till 80, right? So that's you can see the variance between the data points, right? The salary data points and the age data points. So when you put this particular these two features to your machine learning models, your machine learning model will get very may create a problem for your machine learning model, because your machine learning models have to deal with lots of variance and it is not able to converge better. Right? To improve that convergence for your model, what you're going to do, you're going to normalize your data between a certain min or max. When I say min or max, maybe you are going to normalize your data from 0 to 1. Right? It doesn't matter if it is salary, if it is age, but you're going to normalize it between 0 and 1. So you are going to have that differentiator between age, between salaries, one person's salary to other person's salary, but the variance of your data will be less. Okay? Now, second is transformations. So you're going to transform your data. Let's say you have categorical variables. So lots of machine learning models do not act, good with categorical variables because it's a mathematical model and you're supposed to give mathematical, you're supposed to give numeric value to a mathematical model. Obviously, the mathematical model will not going to deal with categorical variables or string. So you are supposed to handle your categorical variable and convert it into a numerical variable so that your equation can use it in a certain weights. So that kind of transformation you're supposed to do. You may remove some features which you feel is not important, right? So you may multiply two features and create a new feature. So that kind of transformation is supposed to do. Now validation is something where you actually validate your data. That is your data important enough? Is your data is the particular feature which you're using for machine learning model makes any sense? For instance, how many of you, if let's say if I have to the use case which I have taken, that you are supposed to recommend a cuisine to a customer uh, based on the customer details which you have, past history you have, and how many of you feel that customer ID could be a great feature to predict for a machine learning model to predict this? How many of you think like that? Anyone? It is not. Gautam, absolutely correct. It is not. And Gautam, why it is not? Or anyone else also can write why it is not? Gautam, you have any idea? Okay. So the reason behind that, as Gautam said correctly, it is not. But the reason behind that is customer ID do not belong or do not give any, know, uh, do not give any importance to one particular class. So let's say customer ID is alphanumeric, ABC123 is customer ID. But if customer ID belongs to one particular cuisine and second customer ID belongs to one particular cuisine, that is not going to give you any insights in making decisions. Right? So machine learning model is not going to give any weight to a customer ID. And second thing is the customer ID will be unique for all the customers. Right? So if four customers buy, let's say, dosa in a restaurant and prefer to eat dosa, but the customer ID for all four customers will be different. So for machine learning model, it is going to be one by one mapping, and it is not going to be important or not considered as important feature for making a better decision. Right. So that's why if something is unique and not helping machine learning models to understand the pattern or behavior or the decision making to improve the decision making, then it is not an important feature and you should remove it. Right? So validation is that part. Featureization is something which I've already explained. When you create new features, where let's say in this particular example, uh, let's say the person who spends $1,000 comes in weekend, and lots of person who spend a high amount of money comes in weekend, and lots of normal people who, let's say, just eat their lunch there and eat normal food and do not spend much and do not come on weekends. That's not a luxury spend. That's a normal necessity spend. So those comes in a different category, and the person who spend high amount in weekend comes in a different category. So based on that, you can create new features, something like high spend, a certain amount of high spend. Uh, comes in weekend is a new feature, and you can remove these two features so that there will be less amount of features for your machine learning to deal with, right? So you're going to create a new feature and remove the two features which already have their information in a new feature. That kind of featureization you're supposed to do while data preparation. And once you do that, once you feel that so I have I have good amount of data. I have dealt with validation. I've created new features. I normalize my data. I know the pattern. Then you are supposed to. There's one thing is missing in data preparation part, which is EDA, which is exploratory data analysis, where you are also, you to or you can check that in featureization and transformations, where you actually learn about the patterns, hidden patterns in your data, and based on that you make decision of featureization and transformation. And once you do that, you're going to jump onto the third stage. Third stage is model building and training, where uh, you're going to select one model. So I've explained about the model. So is it a classification? Is it a classification use case, or regression use case, guys? Yes, so transformation, in transformation, you do other things also, and one of the things is you convert categorical variables to numerical variables, so that for a certain model, so that your models can understand a numeric value, because you cannot give a categorical value or string value to your model where it's a mathematical equation and it will not be to learn anything from that. All right, RA Murli. Okay, so okay, so what kind of use case it is? Is it a supervised learning, unsupervised learning, categorical, sorry, classification, regression? Anyone? No? Supervised. Absolutely correct, Gautam. Supervised. You do not have to put question mark on it. Question. Supervised is correct. Anyone else? So there one is supervised, correct? But in supervised, is it a classification or a regression model? So supervised have two categories, right? Regression and classification. Which one is this? Regression, Sudarshan. Regression, Gautam. And why do you feel it is regression? Okay, so everyone is writing regression now. No, two people have written regression. Other people, all of you feel that it's a regression problem. Other people are confused. Okay, so it's not exactly a regression problem. It's a classification problem, or you can say a basket list or recommendation problem. But let's go with the classification. Why it is a classification problem? Because let's say you have 10 cuisines, right? You have 10 cuisines, and you are supposed to predict one out of 10 cuisines to that customer based on the historical data of that customer. Okay? So if you are supposed to deal with something like that, that means you are dealing with a classification problem. Right? But when in what scenarios it could be a regression problem? The scenarios could be, let's say, if you are supposed to predict that what amount of value that person is going to spend next weekend, right? So I'm Avinash, let's say, and I go to a certain restaurant every weekend or every second weekend, and I spend, at let's say at first weekend I spend around 600 bucks, second weekend I spend around 700 bucks, and you are supposed to create a model in which you are going to predict what would be the amount I'm going to spend on the, let's say, third weekend or whatever the next weekend I come to the restaurant. So if that is the use case, then it's a regression problem, because you are predicting an incremental or decremental amount, right? A continuous numeric value. But if you are supposed to predict that what cuisine I'm going to eat next weekend, or what cuisine you're supposed to recommend next weekend, which is high, which is going to be the high probability of conversion, then it's a classification problem, not a regression. Is it clear, Darshan, Gautam, and other people? Okay, okay, awesome. So once you go to model building and training part, Let's not jump on hyperparameter tuning right now, so it will get confused. Uh, so classification, Raghuvansh, you want to know again? So classification is something where you put a category, where you supervised a category, where you supervise your machine learning algorithm to predict a category rather than a continuous numeric value. When I say category, the category could be, let's say you want to predict a human, you have some features of a human being and you want to predict is it a male or a female, right? And let's say you have some features of a human being and you want to predict that person is going to pass or fail in exam, right? So that is two categories, pass and fail, right? But if you want to predict that if you have if you have some features of a human being and you want to predict what would be the amount of salary he is going to get in next 2 years, right? That is a continuous numeric value, the amount of salary, which could be 10,000, 20,000, 1 lakh, 2 lakh, whatever it is, right? That is a regression problem, right? Not a classification. Raghuvansh? Okay, great. So you build your model, you select your machine learning model based on obviously what kind of use case it is. If it is right now, it is a classification problem. You're going to select out of loss segregation, KNN, maybe dysentery, SVM, that kind of model you're going to select, and then you're going to train that model based on this data, right? And then once you train your model, you're going to test the accuracy of your model. And then once you test your accuracy of your model, you're going to validate based on the information you have. Validation means is your accuracy is good, is your accuracy is correct, is your model. You just need to check. Is there a case where your model is showing biasness? Is model overfit? Is model underfit? That kind of thing you're supposed to acknowledge and check. And if you feel that your model is good enough and you do not have any other creative tuning or changes you're supposed to do in data preparation or model training, then you can deploy your model, right? And you can do real-time prediction or batch scoring, whatever you want. So, and if you feel that no, your model is not predicting as per your requirement, then you can go back to data preparation. You can do some changes here, maybe create new features, maybe do some other transformations, right? Maybe drop some features, and then again do this process. So it is a repetitive process. It's in cycle until and unless you validate yourself here, and then deploy your model. All right. So model testing is something where you generate your model evaluation report, which is model scoring, maybe precision recall. These are some terms, technical terms right now. And in model testing, you go back to hyperparameter optimization if you feel your model is not working good based on your test data set score, and then re-evaluating again with the different hyperparameters or different models, AI models, and then retest on your test data set. So once you feel that your test data set is good, then you have to do model validation. Model validation is something where you check, you just not focus on the test set, not focus on the accuracy. You have to check, let's say, you have to do some cross validation where you check if your model is biased or over fit or underfit on a test data. And if you get this validation through in terminology, in technical terms, we call it cross validation, where you split your test set in small samples and then again test on a different scenarios, right? And then once you feel that your model is working great with different batch of test set, then you can deploy a model on the servers, maybe AWS or something like that. Bye, Shravya. Is it making sense? Okay. Okay, so let's move. So in basics, I mean, when you go to a company as a data science or machine learning engineer, the most of the part, if so, it depends on which company you go to. If you go to a mid-level company, you are going to deal with this whole scenario, right? you're going to prepare data, you're going to train your model, you're going to deploy your model also. But if you are in a fairly large corporate company, then this is the part which you're going to deal with as a data scientist or machine learning engineer, and this is the part which data engineer or big data engineer is going to deal, and this is the part which is where ML ops or DevOps is going to deal. Right, so you're going to focus on this. But because right now you are in college, it's good that you learn end to end from preparing data to deployment. Right? Okay, so it's a regression problem. Let's go through one example of regression. So this is the amount. This is the amount of this house, which is, let's say, somewhere around here, right? 770K price. This is the amount for this particular house, which is somewhere around 170K, 170K, and what would be the amount for this particular house? Right? Can you predict this place? 13,500. Yeah, approximately 13,500. So that's, as you can see, that with this particular line, as you can see this particular line, you can predict that, okay, so amount is increasing from this way, and I can see that some data points are here. My size of the house, because this is the size of the house per square feet, per squared, comes in this particular category. So according to this, if the line increases like this, so my amount should be somewhere around this point. Right? So that's a simple regression problem where a human can also predict. But if I increase the amount of features which we have, like price, and we are supposed to predict price, but we have more features as compared to this size of house price. Let's say we have area, we have number of rooms, carpet area, greenery around it, school around it, and all this stuff. Then it will be difficult for a human to predict the price of the house, right? Because there are lots of dimensions to consider, lots of features to consider. So right, so you have already predicted it. It's around 120, and so so this is the perfect line, right? So this is the perfect line where you can predict to this particular point, 120, and how it actually works. So how you're going to fit that line, right? The way it do is, let's say you have this initial line. So I'm talking about this line. Let's say this line is perfectly fit right now, but let's say in starting, your machine learning model do not know this is the perfect fitted line. So what your machine learning model do? Your machine learning model will going to create line something like this, flat line, something like this. Right? So give me a sec. Right? I'll just check if we have pen option in this, so that I can write something. I don't think we have an option. Okay, we do not have. Okay, so let's say so in starting, our line is something like this, and not perfectly aligned with the data points. So these are the example is these are the data points. The line should be like this, right? Should be like this, so that it is going to consider all the data points and going in between these data points to make perfect prediction. But at first data point, our line is not able to understand the pattern or the regression in between the data. So these are the errors, right? So what we are going to do, we are going to calculate this error. This error plus this error, this plus this error is the total error which this line is making, right? So how we are going to decrease the error, right? So as you can see, if we consider all three errors, this is among the error which we have if our line is in this shape, right? Not going like this. So let's move our line a bit up and check if we are able to decrease the error or not. So as you can see, if we move line downwards, then our error will get increased, and we do not want that. Then we'll check that, okay, so our error is increased, that means our direction of line improvement is what exactly, Gautam? So the predict price input, as I've seen, I've showed you the size of the house is the input, the x-axis. All right. So you're predicting size, you're predicting price based on the size of the house. All right. So where were we? So okay. So we're trying to find out at which direction we are supposed to move to make a perfect line. Right? Perfect line. Gautam, yeah, price do depend on other factors. Right now, we have only one factors. As I said, if we have other factors also, then it is difficult for a human being to understand the price or to predict the price. That's why we need machine learning algorithm to consider lots of other factors and give us the best line or the best uh, equation to predict the price. Right? So this is one example where a human being can also predict, as you did. So now now when you're moving downwards, then our error rate increase. So what we are supposed to do, we are supposed to move upwards, right? So once we move upwards, that means our error rate is going to decrease, and our precision is going to improve, right? So that is called minimize the error, which is done by gradient descent. So we are going to cover that, but just an introduction, and I'm just finding the term right now. So we are going to cover this gradient descent. So a little bit more details when you're going to train a machine learning model. Right? Okay. Now the how you become a machine learning expert in 9 steps. You can decrease or increase based on the amount of knowledge you have or the amount of effort you want to put. So first thing is understand the basics, which we are doing right now. Second is learn some stats. It's important to learn stats because without this, it will be difficult for you to understand the algorithm. And if you do not understand the algorithm, then it will be difficult for you to make decision based on your data. Right? So it's important to learn the basics of stats. Learn Python. Some tools you're supposed to know. So Python or R or both, whatever you feel like, you can learn. Create your first model, supervised learning model. Create your second model, unsupervised learning model, so that you will get both flavors of both worlds. And then do EDA. So do EDA, then run unsupervised learning model, then supervised learning model. And then have some knowledge about big data technology. The reason behind that is uh, the first thing which you're supposed to do is fetch data from DB, right? So if you do not know about big data technologies and your customer provide you, let's say, Hadoop ecosystem or SDFS file system to get data, and you do not know how to query that, then it will be difficult for you to get the data. And then once you are good in these things, then you can explore deep learning models, which is ANN, RNN, CNN, and build some project in that, and then undertake a project which you can complete end to end till the deployment, and that would be then after that it will be all depend on how much new use cases you work on, how much practice you do. Okay, so any question you have till now? After this, we are going to take. Ritika, are we going to take 15 to 20 minutes break after this, and then we'll start with some basics of. We're going to cover some basics of pandas, how to use pandas for data analysis. Anyone have any question on this? Please ask. No. So, are you able to understand what I've explained till now? So I'm just setting the baseline till now. So I have given you flavor of everything in machine learning, how machine learning works, how to how machine learning pipeline works, what are the different models, what are the intuition of that model, what are the application of it, and all this stuff. So, are you following what I've explained? You get confused, please write in the chat so that I can get the feedback. I can understand it, but where you're getting confused, or is it clear? Everything is clear till now. Good question, Deepak. So data scientist and machine learning, I'll tell you the difference. So data scientist and machine learning, people use it interchangeably most of the times. So my designation is machine learning. When I started my career, at least at that time, it was machine learning engineer. And data scientists and machine learning engineer do the same thing most of the time. But the only difference is machine learning engineer deals with creating the algorithm more, uh, creating product through machine learning more, as compared to the data analysis part and just create a predictive models, right? So a machine, let's say you have a new approach to create an ML model, and you want to create that ML model. You have a theoretical concept, and you want to create that model as a library, or want to create that model as a feature in your product. Then you need a machine learning engineer to do that. So machine learning engineer have a lot of core software engineering skills, data structures, algorithms, and all these other important skills a machine learning engineer should have, plus the data science knowledge, the stats, the ML models, the EDA, and all this stuff. Right? But data scientists generally deal with the data analysis part most of the times, and sometimes they deal with predictive modelings and create some models, check the accuracy of it, and give that models to infra team to deploy it, right? And the data scientist is supposed to explain their decision, whatever the model analysis they did, the pattern they are able to recognize to the stakeholders. When I say stakeholders is someone, let's say the client, let's say the CEO, let's say the management, right? They make their suggestions to the stakeholders based on the data analysis they have done, right? So the pattern they're able to find out through the data. So they're supposed to be a good communicator. Data scientist is supposed to be a good communicator also. They're supposed to give that story, create a story of data to other stakeholders. So that kind of client interaction is more in data scientists as compared to machine learning engineers. So that's a slight difference between ML engineers and data scientists. But people generally use these designation interchangeably. So industry can abuse these words. So such difference exists. Okay, Deepak. Anyone else have any other question? Okay. Ritika, are you on call?
Yeah. Yes.
Okay. So Ritika, can we have 20 minutes break now?
Okay, great.
Is everyone back? Am I audible? Okay. Thank you, Deepak. Okay, so I hope my screen is visible to all. So next few hours we are going to spend in cementing our knowledge using the pandas specifically, and cementing our knowledge to how to do data analysis on any kind of data. So to do that, we are going to use a data set which is it comes from Uber, and the data set. So the use case, the case study is that the data of a driver's Uber trip are available for year 2016, and your manager wants you to explore this data to give him some useful insights about the trust behavior of a Uber driver. Right? So why your manager want that? Because your manager will going to, based on your analysis, manager will going to make some business decision which ultimately turns into a uh, value generator for business. Maybe let's say you are saying that this particular area of Uber drivers do not. There are lots of Uber drivers in this particular area, but they will not. The frequency of getting rides in this area is very less. So lots of Uber drivers just sit there and do not get enough rides. So you can move some of those drivers to some other area where you have lots of congestions. So that kind of decision making your manager can do if you are able to analyze Uber data, right? Uber trip data. So, what are the columns of the data? So you can see that the columns it contains is start date, end date of the trip, start location, from where it start, and location, miles driven, purpose of drive. So sometimes I think in India they do not have this purpose of drive when you book an Uber, but maybe Uber is running some kind of different vertical where they uh, give rights to the people of maybe business people, maybe hotel or something like that, where they specifically mention the purpose of drive. And so you have these kind of features, right? So what are the steps you're supposed to follow to achieve this? So the first thing is obviously you're supposed to import libraries, whatever the libraries you have, you're supposed to use. The second thing is get the data and observe it. The third is check missing values, either remove it or fill it. Why we are supposed to do this part? The reason behind this is because you cannot work on null values or missing values. It will not add any value to your overall analysis, right? So it's better to remove this to make your data analysis more simple and remove the complexity from this. And then you're supposed to get summary of data using Python functions. So when I say Python function, it's more of pandas and Python functions. And then you explore the data parameters wise, what are the in each parameter it have, and then you're supposed to give some kind of insights if you're able to find out some kind of insights from this data. Right? So what are the concepts we are going to cover? So obviously we are going to cover how to handle data, how to clean data, how to remove null values, may not be how to find at least null values for this use case, and then how to do group by function, how to use apply function, how to handle date time operations. Right? So that kind of thing we are going to learn through this case study. Right? So people who do not have any experience with libraries like pandas and numpy, so this is numpy, this is pandas, and if you are supposed to, let's say, install pandas, for the people who do not know, I think you've already written that most of the people know how to use Python. So in Python, if you want to install some things, you can go with pip install and the library name, right? And if you want to do the same thing, in Jupyter Notebook, you just need to put exclamation mark in front of it, and Jupyter Notebook will act as a command line or terminal and install this for you in your Python environment, right? So once you're able to install NumPy and Pandas, let's go through how you import numpys and pandas. So firstly, you're going to import is a basic standard way of importing libraries in Python. So import numpy, right? Whatever you have installed as np. So why as np? As np is nothing but it's a reference point. So you have imported NumPy, but whenever in your whole code you're going to call NumPy, you're not going to say NumPy. You're going to say as NP. It's a short form. It's a global. Globally people use this NP as NumPy as short form. You can also do that, and if you do not like it, you can change it whatever you want. You want to say NPY, you can do that, right? You can use NPY also. So similarly for pandas, you imported pandas, and then you have assigned object to that pandas that you can use this reference name ed whenever you want to use pandas in your code scenario, right? So this is our dataset uberdrive.csv. So after today's session, I'll share this CSV file with you, so you can do hands-on with by your own and experiment with it, right? So the first thing which you're supposed to do is load data. Okay. So once you load data and then read data, or you can say read data, then only you can do any kind of operation on this particular data. Right? So you have CSV. So let's say you have CSV. I think somewhere here. So you have CSV here, Uber drive.csv, and you get. That's why I'm not given any absolute path because it's the same directory. And then you can use pd as pandas dot read csv, right? And then put the CSV name in, right? So read CSV is, you know what is CSV? Remember? Anyone of you do not know about CSV? What is CSV? You can write in chat, comma separated value, absolutely, Sarvya. So it's comma separated value, so it's comma separated value. Raghuvansh, don't know. Okay, so let me show you how CSV look like. So it look like something like this, right? The first row, as you can see, is your column. It is considered as a column, right? And is separated with comma. As you can see, this is comma. Okay? Is separated with comma. And the second row is considered as row. Right? So the first row or index, I would say, I'm not going to confuse you with row and row. So the first index, like 1, is considered as column, right? As header, and then the remaining all the indexes is considered as row, which is data, right? And when you use CSV, so it's a simple way of creating your data set or persisting your data set, where you do not have to make complex structure. And when you read this into, let's say, through pd.read csv, it looks something like this. This is your column and this is your data. All right. So there are many other ways to read this. So CSV is not one way. So there are other ways to read data, which is let me open this if I can. So you can read SQL also. You can read TSV also, tab separated values also. I think it's not coming up. Okay, so you can check. I'll share the link of documentation of read CSV or read for pandas. We will have different values. You can read direct Excel. You can read CSV. You can read SQL, JDBC, right? These kind of stuff you can directly read from pd.read. Right? So once you read it, that means you are able to get data in DF format. So the people who already know about pandas, can you tell me what is DF or data frame? What is the structure of data frame? Anyone? Some people have written that they use pandas earlier. They have some knowledge of pandas. No? Okay. So you know about data structures, right? How many of you know about data structures? At least the CS people, IT people. Do you know what is array? What is, yes, Raghuvansh, no? Sarvya, no? Okay. So do you know what is 2D array? Two-dimensional array? Raghuvansh, Sarvya? Okay. Arushi also knows. Okay. So the people who do not know about uh, array or do not belong to CS or IT background, so let me. It would be better. I can. Give me a sec. Okay, let me create a new document for you. Okay. So, are you able to see the whiteboard? Just share yes. Okay, okay, fine. Okay, so let's learn about some basic data structures of especially the useful data structures for data analysis. One is, so in the simple term, we were dealing with earlier we were dealing with, let's say, a simple array. This is a simple array. Let's say array. What is a simple array? Array starts from index 0 and goes to n index, so whatever the size of the index it is, right? So at the first index, you are storing some values. Let's say the value is 25, then value is 57, then some 84, something like that. Right? So this is a simple one-dimensional. Let's call it 1D. Right? This is one dimension. We are storing some value from 0 to n index. Right? Now, if you are supposed to deal with, let's say, if you are supposed to deal with an array where you have more than one dimension. Right? So if you have array like something like this, first array, second array, third array, and you are supposed to insert some value, let's say x1 till xn, y1 to yn, and z1 to zn in this array, right? Now these are single array. This is 1D array. This is again 1D array. This is again 1D array, right? But if you combine this, and put it in one simple array, any one object, let's say array object, what this array becomes if I combine these 1D arrays in this matrix? Absolutely. And in terms of array, in terms of computer science or data structures, what you call it? Two D array. Absolutely. 2D. Not exactly 3D. It's 2D array right now. Arushi Gandhi, correct. It's data frame, but there's a slight difference in the data frame for this. So this is 2D array, right? Now, if I want to increase the dimension of it, let's say if I want to increase the dimension, I want to add one more dimension, which is obviously difficult to visualize in terms of data. But if I want one more layer of dimension, let's say in terms of pictures, we have one more dimension, which is RGB, which is color dimension. Right? Now that this will become 3D array. Correct me if I'm wrong, right? Correct. Images, right? So 3D array. Now, if you want to store this, if you want to store these kind of data into an object, into a Python object, let's say, into a Python object, and you want to do some operations on it. You want to do some operations on it. Let's say you want to just just calculate the sum of this particular index, sum of index 1. So what you have to do, you have to again write a function where you go to first index, whatever the index in your function is. So let's say you are going to write, function sum on index, and then you're going to get, you're going to ask for index, and you're going to return sum. Right? This is going to be one function which you're going to create with this one particular task. So this whole handling or operating or processing this 2D or ND array, I would say, ND array of data. If you want to deal with that, then Pandas provides you out of the box solution, which is data frame. And the best thing about data frames is it is optimized for a certain task. Let's say if you want to do a group by, if you want to do, let's say if you want to count on a particular column, let's say count and all this stuff, the data frame is optimized and have will give you out of the box functions to handle these kind of scenarios. So this is the crux of data frame and why pandas prefer to use it. So in simple terms, intuitive terms, data frame is nothing but the representation of your data in a structured format which you can process. Right? If you repeat it, the representation of your data in a structured format which you can process. Right? So let's go to our use case. And so this is our data. We have column start date, we have column end date, category, start, stop, miles, and purpose. So anyone have any question on this, the data frame explanation? Okay, great. So so we have data, right? Now whenever you get the data, right, you do not just jump on building machine learning models. Do not just jump on, okay, so I have data, now I'll build a state of the art models, I'll be Kaggle winner and all. So you do not have to do that. So first spend some time on data. So first understand your data, that what are the features or in your data have, and what are the things you can do with your data. So uh, before just having some pre-assumptions about your data and everything else, just look at your data and see that, okay, so you have a start date, right? So because you're dealing with Uber, you have a start date, and check just a glance, check that, okay, so it was written that it is for 2016 years, so it is 2016 years, that's true. And the end is at 2016 years, that's true, right? So it is from 2016 years. We have a category, so category is a business, so that means there are some categories available. These are not null, they do capture categories. And we have a start point, which is for years, someplace maybe US invest. And then we have a stop place, which is again, start and stop, source and destination. How many miles it covers? So it covers 5.1, 5.0, and all this stuff. It has covered a lot of miles, 3.7. What is the purpose of this site? Right, mean entertainment. This is NAN, null value, which is not available. We have meeting, and all this stuff, right? So these are things you can check. And what kind of things you feel that you can find out? Let's say you do not have to do any analysis. So first, what kind of things you can find out through this data as a human being? What kind of things you will be interested in finding out at least? Anyone? Are you able to understand my question or getting confused? For instance, let me give you a starting example at least. So let's say if you want to find out how many how many people go to Fort Pierce, right? from a certain point, let's say they start, how many matches of start and stop are there for 4 peers at stop, and the purpose is meal and entertainment. Like what this thing can give you is, let's say if Uber want to collaborate with a certain restaurant in this particular place for 10 peers, and Uber will give them the data that lots of people from this particular area, let's say this is for 10 peers, let's say lots of people from West Palm Beach area go to four peers and have meal there or entertain or just watch some movies. So if Uber can show these people that data, then people, when Uber book a cab or someone book a cab from West Palm Beach and go to Fort Pierce, Uber can pitch them certain offers so that maybe the person want to go in XYZ restaurant, but with that particular offer they will go to ABC restaurant. Right? So that kind of conversion Uber can take if they analyze their data well. So any other thing you feel, if you are the person who is going to analyze this data, can find out? Anyone? No? Okay. No issues. It's just a starting point. Let's dive into how we start analyzing. Firstly, how we clean the data, and then how we start analyzing this. Right? Okay, so the first thing you are supposed to do is obviously, so this is the part when you do df.head. Head means the top certain amount of data you get. So the amount which you have mentioned is 8. The default amount is 5. So if you do not give 8, then the top five data you're going to get to visualize. Right. So this is just for visualization purpose. So you can check your data. Now, and if you want to check the bottom x, then this could be the x value. The 10 could be the x value, and you just need to do df.tail, right? Head and tail. Right? It will give you the bottom x value. Okay. Okay. So let's understand the shape of the data. So the shape of the data, as you can see, is if you do df.shape, it is going to give you the shape, which is these are the rows, number of data points you have, and these are the columns. So we have 7 columns, right? We have 7 columns: start and category, start and these, and we have around 1,800, 1,156 rows, right? Which is totally equivalent to 8,092. Now, if you want to check the data types of your data, then you just need to do is df.info. And one more thing, how many of you know how to write SQL queries in MySQL, MSQL, Oracle, wherever it is? Anyone of you have knowledge about SQL, 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 what do you call? Sudarshan have. Okay. Anyone else also? Sarvya have. Basics, Abhinav have. Okay. So why I'm asking this is, if you already have knowledge about SQL, then it will be very relatable to you. Lots of things which we do in pandas can be done by SQL easily. Right? But why we need pandas is, pandas give you more flexibility to use Python for data analysis, use Python for data transformation, and then use Python for model building also. Right? So you do not have to do that thing in SQL, then get the data for machine learning models, right? So if you have knowledge about SQL, then it will be easy for you to at least understand the intuition that what Python, what pandas exactly is doing. Right? So, uh, so with df.info, what kind of information you get? So the information which you get is the number of rows belongs to this particular column, which is 1156. What kind of do we have any what kind of data type it has? It has object, it has This is object data type, this is float data type. So object data type is nothing but a category where you can put some category, some string value. So these are the data types. So we have 6 object data types and we have 1 float data types. Right? So as you remember, I've explained that you are supposed to, when you deal with machine learning models, you are supposed to create, you are supposed to handle categorical variables and convert that into numerical values and then feed to the machine learning models. Right? So these are the categorical variables which you are supposed to handle once you deal with your predictive models. Yeah. Okay, so now let's say if you want to find out the count of each column, right? So these are the count of each column. So start date have 1156, which is correct, and date have 1155, and similarly for others. So which particular column do you feel have lots of null values? Especially people who know about SQL, they can answer it. Purpose, absolutely correct. Now, and what are the other? So apart from purpose, do you think other columns also have some null values? And date. And date have, category have, star have, stop have. So these, as you can see, the highest is the number of columns. The highest number of columns is 1156, and this is 1155. So one null values you can expect in these columns, and lots of null values in purpose. Right? Smiles obvious. Smiles okay have. So and now, if you want to, we can see that we can also analyze through this df.count. But if you want to specifically check what is the count of null values, what you do df. So every data, the data which we have is in df data frame, right? It's an object, and then you do dot is null. This will give you the true value where the column is null, the row cell is null, and then you do dot sum. But dot sum will give you, dot sum will calculate all the null values per column basis and then give you the output. So in start date, you do not have any null value, so it's 0, and date have 1. Similarly for purpose, you can see that 503 values are null. Right? So that's a way. It's a other way to find out the amount of null values it carries. Now, if you want to just check that in your whole data, do you have any null value so that you can take decision based on that? So let's say you are supposed to write a script in which you have, you are supposed to take decision that should you handle null values or should you not? So to make that decision, you obviously have to check first. Do you have null values in your data or not, right? How you do that? So one way is to do is you do just df.isNull.sum. You'll find the sum, and then you iterate through this. And if you feel that any column have any any value which is greater than 0, then you'll consider that yeah, so this data frame contains null values. The second way is, the simpler way is, you just go with df.null, which is similar to this. It's going to give you all the null values with true, and then you check any, and it will give you true with in terms of column, and then again you use any, which is going to give you one true value. So if any of the column have any null values, any count of null value, then it is going to give you one true ultimately. Right? So you can use that to put that validation in your script. And so if you just use this part and not this part, then you can get something like this, which is start false because it do not have any null values, and all other have null values apart from this miles, and you can make decision on true and false based on the null values. All right. So if you just want to fetch all the columns which have null values, right, and you want to make lists out of it, and then maybe you want to do it, or maybe just you want to remove it, whatever is your purpose, you can do it just df.isNullAny, which is again this part, right, and just put it in the df.column. So df.column will give you all the columns, the 7 columns which you have, and then just it is going to give you, so df.column, and it's going to give you the output as all the columns which have null values. Okay. and then you just typecast into a list and then use that list in this way. Right? So all the columns which have null values you will find. All right. You have any question till now? Anyone? Everyone? Okay. Okay. How many of you used these things in pandas earlier? Maybe some of it. Anyone? Okay. RA, Murli have used. Okay. So I think no one else. So let's move forward. So this is how we handle null values. So let's move forward with uh, other ways, right? So we have handled null values, right? What we should do with null values? So the two things which, I mean, there are many things, but two commonly used things which we can do is you can drop NA, which is a function where wherever you find null values, you can drop that. And so when you drop this, then the whole column will, the whole row will get dropped. Right? And the second is you can replace with that in df.purpose we have you can use fill NA, which is fill null value, and then you can replace the null value with some text if you want, or some numeric value if you want, based on the column type, right? So you can put no purpose so that you do not have to deal with the null values. In place, this is in place, which is just going to replace everything in purpose. Wherever you it will find null, is going to replace it with no purpose. All right. Now, if you, let's say if you want to rename columns, the second thing is if you want to rename columns, what you do? So this. Let's do the renaming columns. Okay. So now, as you can see here, is we have, so our data have star in the column names, star date, star date star, and date star, cat date star. So if you want to remove that star, right? So what we can do is we can just firstly we can just use all the column names without star, and then we can replace that in the df.columns as a list, then it will going to replace it. This is one way to do it. Second way to do it is if you want to replace it on the basis of string replacement, you can do df.column string replace and then replace your string, which is star. Why I'm saying star, if you get confused where from where I'm saying star, it is this part. As you can see, and date star, category star, category star, and date star, start star. Okay. So if you want to replace it, so if you want to manipulate your columns, let me say, if you want to manipulate your columns, you can use this way. Just replace all your columns with the new columns. If you want to manipulate your columns in this string format, you can do that. And if you want to just replace your columns with something else, let's say category with cat, you just need to do df.rename column, put the column category and then column cat, and you'll get rename, the column get renamed, right? So this is one way to rename it. As you can see that all the name has been changed, all the category which we have used as category name is changed to cat. Now, let's say if you want to put filters, as many of you must have done in SQLs, if you want to put filters and filter data on some conditions, how you do it? So in df.purpose, okay, one more thing which I want to highlight here is, as you have seen that we earlier we had purpose star, right? So if you can use df.purpose something like this. You can also use df purpose, something like this, right? Both ways you can use if you want to access a column, and if you if you have, let's say, uh, if you have if you have a star here, let's take a star here, then you will not able to use this way of accessing a column, right? So you cannot use df.purpose. You have to use this way of accessing the column, right? So that's why we have removed the star earlier, so that we can show this way of using your column also, right? Now what we're doing here is we are just accessing all the null values if purpose have any null values, and then we are accessing that data. So it's a filter for us, right? So df.purpose.isNull is a filter for us. And if you do not want null values and you just want non-null values in purpose, you use inverted. So you use inverted to whatever the condition is. It's like not in our coding environment, not equal to something like that. So if you use inverted, so whatever the data you have, it is get inverted, and the data which you're going to get will not have null values in it, right? So this is one way to filter, and the other greater than less than filter if you want to apply. So you can directly apply, this is df, which is your main data frame. Then what you're doing, you're putting a condition called data frame miles is your column, this column, and the condition which you're putting is df.miles is greater than 30. Then give me the data where df.miles is greater than 30. And you can do it with df.query also. You can directly put your SQL query to run the same condition, right? And the third thing is obviously the inverted, the thing which I've said earlier, that not equal to also you can use, equal to or not equal to also you can use based on the filters. So whatever the filter you want to apply. Anyone have any question on this filtering? Okay. So it's a simple stuff. Filtering is simple stuff, and let's say you want to get the max and min value, right? So df.miles.max, if you apply, you'll get the max value. Then df.miles sort value, if you want to sort it in an order, let's say ascending false, you want to sort it in a descending order and get top 10, you can do that. And if you want to again compare that, I want the max row from df.miles and df.max value, whatever it is, let's say is 1000, and I want the row which have max miles, the maximum number of miles the row have done. I want that particular row only to analyze, so you can do that. Again, this is just a filter condition, right? That kind of thing you can easily do without writing a SQL query or without writing any complex query. You can just simply use df pandas to analyze all these out of the box functions, right? So so let's dive. So if you want to check for length, you can do that. You can do df dot count also, and that will give df the size also, that will give you that, and you can use length df also, and that will give you the size of your data frame. Okay, so one important thing which apart from that, that data type we have already checked, right? So this is a different way apart from info, df.info. But one important thing which normally whenever you deal with data, you are going to do it, and most importantly, you may be doing it in the early stage of data, which is df.describe. So what describe will actually give you is it is going to explain you about the numeric column of your data, which is miles in our case, and give you some descriptive analytics, descriptive statistics about your numeric value, right? What is descriptive statistic? Which is mean, standard deviation, min, 25%, first quartile, second quartile, third quartile, right, and next. Uh, Can anyone tell me what are the benefits of finding these things? What are the benefits of mean? Or can anyone tell me what is standard deviation mean? Mean equal to average. Okay. Standard deviation. Anyone? Variation from the mean value. Absolutely got it. The amount of variation from the mean value, both sides, positive and negative, will be considered as standard deviation. And what is the use of standard deviation? If anyone can, what is the use of standard deviation? As I think morally have written that consistency of distribution. So basically, the mean which you, because you cannot average amount of variability in data set, correct, Nandini? What actually, when you, let's say, dealing with the distribution of a data, let's say what kind of distribution of data is, say, it's a normal distribution, right? And you are supposed to check that if I deviate my data from mean this much to left and right, how much data I'm covering in it, or how much data points, how much percentage of data I'm covering in this one deviation in left and right. And if I do a two deviation from mean, then how much percentage of data for decision making, obviously, I'm covering uh, to if I deviate two deviation, like from the mean. So if you can understand that, so you can understand that the distribution of your data, and you can understand the you can create the probabilistic models, maybe probability density functions, and try to give a probability for a certain questions. Right. So I mean, when you learn about the stats and details, you will get more detailed view of it. Or when we'll do the EDA part, then we'll cover some basics of it, right? So that kind of thing with just one simple function df.describe, you can find out the count, mean, standard deviation, min and max, and the percentile. So as what is this quartile is with 25% of the data, let's say from min to 25% of the data, the miles range is 0.50 till 1.77. Right? And the next 25% of the data is ranging from 1.77 to 2.50. And then third quartile of the data is ranging from 2.50 till 3.40. So if you see, your 75% of the data in miles covered in the range from 0.50 till 3.40, right? And your 25% of the data is from 3.40 to 4.90. So you can see the distribution is quite good. It's approximately same amount of change in variation in change in range happening from 25% to 50 to 75, right? And to max. So as you can see, the miles driven range from 0.5 miles to 105 with an average of 21 miles uh, and the max miles, which is saying that it look suspected. Why it is looking suspected? We need to find out that. Uh, is it outlier? So there's a different concept of outlier. So is it an outlier? Only one or two rides happen with this range, right? And if you want to drop, so I've already explained. We have already checked that if you want to drop columns, drop any null values. So how you can do that, right? One important thing. So what we have done till now, and you want to do it, you want to analyze your data in a simpler format and with just one line of code. And there is a way to do that, which is pandas profiling. So whatever null values analysis, correlation analysis, cardinality, this describe function, all this stuff. You do not have to write a code for this. Some awesome people, you can check this GitHub profile, which is pandas profiling, pandas profiling. You can go to this GitHub profile and check their documentation. The thing which I want to highlight here is you just need to import pandas profiling once you install it, and just give your DF, which is data frame, to this pandas profiling, and with profile to file, you're going to get an HTML file which is going to have all this information. Let me check if I have one. Yes, I have. So it is going to look something like this. So as you can see, uh, all the data set info, the number of variables you have, the number of observations, total missing values, total size in memory, all this stuff. The cardinality in your data, which essentially tells you that it's a categorical variable but have high cardinality. That means lots of categories are there, distinct values are there, and it is a warning for you. So you have to handle this. And again, same for stop, and lots of missing values. So as you guys remember that we checked missing values with is null and all this stuff. Once you generate your portfolio, your pandas profiling HTML page, you will get that. Okay, so the purpose have 50% of missing values. That means you're supposed to handle this amount of missing values, right? And the distribution of your data. Let's say what are the first three values, last three values of it, right? What are the categories, different categories? So there are two categories: business, which is 452, 91.1%; personal, which is 8.9%. Only two categories are there. What is start categories, which is carry, white bridge, Morris Village. So lots of people. There is no biasness in this. So we have different categories. So it can show only some categories. As you can see, 7.7% categories come from different places. You want to see correlation, you can check correlation, Pearson correlation, Spearman correlation, and sample data. Right? So that kind of thing also you can do with your Panda profile. Right? Let's go to our Panda profiling thing. Okay, so you can explore that through this GitHub repo in details. Now, understanding the start and stop point. So we have start. So if you want to understand the start point, what are the start point? You can see that you can check all the unique categories in this. So what are these categories? These are the start points of places, source, right? So Fort Pierce, West Palm Beach, Cary, and all these other places where Uber starts their rides, right? And that is captured. Okay. So how many of unique values we have in start point? So we have 177 unique values. How you'll find it? You just finding start df.start with unique. It is going to give you this list, and when you have one list, just you need to put that list into length, and it is going to give you length. Right? So 177 starting points we have. Right? So if you are in India, let's say, just to make you relatable, if you're in India and you ride from uh, let's say Chennai to Bangalore, that would be one ride. Your source, the starting point will be Chennai, and your destination will be Bangalore or some place in Chennai. So similarly, the starting point we have is the unique starting point we have is one sensor. So lots of maybe Fort Pierce have 10 rides as starting point. West Palm Beach have 20 rides as starting point, but we are just finding out the unique values of starting point. Okay? So similarly, we are supposed to find out the unique values of stop points. Okay? We have around 112 stop points, which is destination, and we'll find that in a similar way as we are able to find start points. Right? Now, so if we just want to check again, or if you do not want to use unique, you can also use set. Set is a disaster which do not allow duplicate value in it. So you can use set and fetch the start values and stop values data, right? And so once you are able to do it, if you let's say want to find out the difference between these two lists, I'm just giving you right now. We're going to do it in these on these lists also, but I'm just giving you some intuition about how you can find out difference union intersection between two lists. So you have two lists, right? L1 and L2. Right? If you subtract L2 minus L1, what you're going to do? So what will be the output of it? The first one, L2, L1. If you subtract L2 to L1, 1 and 2. Okay. Why not 5 and 6? Sudarshan? Anyone else also want to answer this? Are you able to understand what I'm trying to ask? Okay, Raghuvansh also say 1 and 2. Sudarshan saying 1, 5, 6. 1, 2, 5, 6. 1, 2, 5, 6. Okay. So to do this, let me run this. Okay, so first, show this. Let me comment this. So this. The answer is 5, 6. Right? Why? Anyone? Why it have not included 1, 2? Yes, correct. L2 minus L1 it is. Right? That's why. If we do L1 minus L2, what will be the answer? 1, 2. Correct. Okay. So you understand, right? What how it works. So similarly, if you want to find out, let's say union of these two, what will be the answer of union? Anyone? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, right? Correct. Now, if you want to check out the intersection, can you write the answer of intersection? 3, 4. Absolute. Let's check. 3, 4 days, right? So you get the gist, right? You get the gist why how it exactly works and why we are trying to find out this is because we have two lists. We have one list of stop. We have one list of start. Right now we want to check how many people how many common areas of start and stop we have, how many intersection of start and stop we have, and how many, maybe it is not that the same guy uh, start the same, is the same guy from the same ride starts and ends the same ride, but the different guy with the same place starts and the different guy with the same place stop, right? So let's do the same thing on intersection we have done. So let's do the same thing on our data, start and stop data. So these are the intersection which we have. These are the places. These are the common intersection we have. And what are the count of popular start point? Top 10 popular start point, if you want to, if you want to find out. Uh, So top 10 start points is Kerry. So 73 people starts taking rides from Kerry. That the possibility of this, so some kind of assumption we are supposed to make. It's a story, right? So the possibility of this is maybe that place is that place have some kind of SEZ or some kind of corporate which usually take cabs from one place to other or for house. So that's why many number of people prefer taking cabs in Kerry, right? As compared to other, let's say, Nugegoda. And similarly, lots of people go to Kerry also, right? So this indicates that, yeah, so Kerry is a high density maybe or high corporate offices density places where people prefer to take cabs rather than going by their own vehicle. And maybe the net worth of overall cluster of Kerry is more as compared to other. So that kind of insights you can get from these values. Right. So what you are going to tell your manager? You're going to tell your manager, okay, so Kerry is a place where lots of start and stop points are there. That means we need a lot of cabs density in Kerry and Whitebridge, maybe even the Greater Whitebridge also. And so the places where, if let's say in Burthros, if we have less, if we have more cabs in Burthros, and we see that in 1 year there are a lot of only one start were there, a very less number of rides were there, then we can move those cabs and ask those cabs to move to Carrier, Whitebridge, so that we can overall, improve the revenue. All right. So, and if you want to check that where is in which particular data point we have start and stop in the same ride. So as you can see, that's the person starts from Fort Pierce, ends at Fort Pierce. The person starts from Kerry, ends at Kerry. Right? So, the small rides, 0.8 mile, 1.6 mile. So that kind of reading you can see. So this also again trigger the same assumption or the same hypothesis which we have taken, that Kerry have a lot of cab density. Maybe that cabs can go outside Kerry or maybe Kerry, but the movement of cabs is more in Kerry as compared to other areas, right? So now you can, okay. Can you tell me what is the purpose of group by the people who use SQL earlier? What kind of solution? What kind of flexibility options a group by can give you? Or you can just explain what is group by. Anyone? If anyone is trying to answer something, you can just say yes, and then I'll wait for the answer. No? Okay. So, what group by tells you is, let's say you want to check in this particular data, so let's say example of this. So you want to check again based on carry how many miles, the total miles people have uh, taken rides in Kerry, right? Where the start point is Kerry. How many miles, total miles, or it equivalent to the total revenue generated for Uber, right? So if you want to group based on category and with the and map or try to find out some average of some other column based on this category, then you can use group by. What we are trying to do here is you are doing group by on start, which is this Kerry, Maurice Valley, and Whitebridge, and then you are selecting one particular column which is miles, because we have only one numeric column. All other are date time column or categorical column, so you cannot do sum on categorical column. So we have only one numeric column, so we have selected that miles, and we do sum on it, right? So what it is giving you, it is giving you if the start point is first is Kerry, and then it is going to give you sum of all the occurrence of miles in start Kerry, right? It is going to add 0.8, 4.8, 1.6, 2.4, and give you final sum. Now you want top highest value up, so then you can sort value also, sort underscore value. Ascending equal to false, that means you're dealing with descending orders. So last to low, and then you want just top 10, right? So if you do not give this, then all values it will going to show, but you just need to check top 10, then you're going to give dot head 10, right? So this will give you group by sum on this. So again, so whatever the assumption we have made that the carry is a place where lots of revenue is generated for Uber. So if Uber can check that, if so different, so other way to evaluate this is, do Uber have lots of cancellation, or people are trying to find out cab but they are not getting cab in Kerry? If Uber feels that this is the case, that means the demand supply in Kerry is so that the supply is very high, so demand is very high but the supply is quite comparatively low in Kerry, and Uber can take business decision to uh, you know put more cabs in Kerry and Morris Valley, so that to obviously to improve overall revenue. Right? So other thing is you can do plot analysis also. As you can see, with the same sum of miles, you just need to put C import Cborn as SNS. We are going to learn about this in EDA part. So you're just going to give Cborn SNS and just give the column name. Sum of miles is going to give you this beautiful chart to understand that carry have 200 plus miles, and then similarly other start points, right? And if you want to combine, let's say earlier we were just using group by for one column, you can do it for two columns also. So it is going to give you a combination of start and stop, and then calculate the miles. So there are lots of communication between Morris Valley and Kerry to Morris Valley. So lots of people, maybe the chances that lots of people live in Morris Valley and travel to Kerry for job, and vice versa, possibility. And that's why the more number of cabs you can see between these two cities, right? And maybe these two cities are relatively near as compared to other cities, right? So for value generation, you can focus on these two cities, right? So combination of these two cities. Now, lots of if you do not want to deal with unknown location as start and stop, you can just remove it by not equal to. So you will get data which do not carry unknown location in start and stop. Right? Okay, so we so again this is just the same thing, but in terms of size, let's say if you want to just how many data points, earlier we were calculating sum, now we are calculating data points, right? So 41 rides have been taken from Morris Valley to Kerry, and from Kerry to Kerry 37, and from Morris Valley to unknown place, I believe. No starting place to 34, and Islamabad to Islamabad 23. Okay, so the most popular start to destination pair is Merseyville and Kerry, as we have already discussed. Right? Anyone have any question till now? Do you feel value in understanding this? You can write no if you feel you do not get any value in understanding this. Okay, thank you, Shravya. Uh, so other people are sleeping because we are not interacting in person. Only few people are writing on chat. Gautam Krishna. So you are writing no for sleeping, or you're writing no for you're not getting value. Achha, no for sleeping. Okay. Awesome. Great. So as you can see that it's not that fancy. The way we deal with data is not that fancy. It's not that interesting in some way. But if you approach a data with a assumption, or with the curiosity to understand data, that the thing which we are able to understand, that these two pairs go together, and we can generate more revenue through this, so the business decision making become much more easy. And that is the problem you are solving with data analysis, right? And with data science, right? So you are supposed to uh, give more insights to the stakeholders to make their decision easy. But seems like a lot of algorithm to keep in mind. No, these are not algorithms, Gautam. These are just this simple, analysis of your data. So it will come. I mean, as you practice more, you get some intuition that, okay, so if I have this kind of data, I should. You just have to be Sherlock Holmes. In a simple terms, I just want to say, you just have to be Sherlock Holmes. You you can act as a detective on your data and check what kind of insights you can get, what kind of manipulation of data you can get, so that you'll find out some patterns, some insights. That is so we have not covered any algorithm till now. So we have discussed the algorithm, intuition of the algorithm, but all the algorithms, some algorithms, one or two algorithms from supervised learning and clustering, and some NLP part we're going to cover in the process, right? Okay. Now, one important handling which you're supposed to do, which is date and time objects. As you can see, as you have seen, we have not touched this part, right? We just dealt with cat, start, stop, miles, purpose, right? But we have not touched start date and end date till now, right? How we do that? So to get important insights from these two, there are different ways to deal with it. First thing is, you are supposed to, because right now it's a categorical variable, it's just a string, but firstly you're supposed to convert it into a date time object, so that you can get insight from it. So how you do that? We have a apply function, which is again an anonymous function, which is lambda x, anonymous function, which is lambda x, and the date time string, right? So if you want to check more in details, you can go to this particular URL. You can check the documentation. But the simplest thing which we are doing is, we are just converting this format 1 to 2016 2025 into a datetime object, which is in this format, which is month, day, year, hours, and minutes, right? We're just converting that. So we have two columns right now, which is date time in nature, which is start and end date. So we are going to convert that and store in a different column. So it's a new column. Start date underscore dt is a new column, right? So when we are going to run it, so it is going to convert it and store it in a new column. As you can see that these two old columns, start date, end date, is an object type, and these two columns now is date type, right? It's date type. Okay, so now when you have daytime, then what you can get out of it? Now, once you have daytime, now you can create new features, right? As you remember, I have explained about the feature engineering, where you create new features from one feature. We are going to do that here, right? So, so we have this column start underscore dt dot day. But dt dot day will give you dt dot day will give you start days, only the days part, only the dd part, right? And store it into a new column which is start day. R, if you want to analyze R, then you're going to do start date underscore dt underscore R. It is going to fetch R and store it into R. And similarly for month, similarly for day of week, right? So how your data manipulated? This is your data transformation, right? How your data transformed? Your data transformed from this particular row value columns to and added this particular row value column. So these are the date times. These are the new columns. Start date as second. This is the part which is start date. Okay? This is the part fetched, which is day, and stored into a new column. Similarly, this is the part that the R20 is fetched and stored into a new column. Same for month, this one, and same for day of the week. So whatever the week it is, so it will calculate internally the week, that fifth day of the week or the fourth day of the week. And so why you need? Can anyone tell me why it is important to focus on day of the week also? Any pattern you see in increasing or decreasing the amount of cabs people take uh, in a particular day of the week? Working days or weekends? Absolutely. More people will travel in holidays, right? Absolutely. There are chances of more people will travel in holidays, but it's a cab, Gautam. So it's a cab service. Maybe we may not be able, we may not focusing on the outstation cabs. We may be focusing on intercity cabs, in intracity cab. So I mean, if we are also considering outstation cab, then absolutely right. So more people will travel in holidays, right? It measures the time. It measures the time. Nandini, how it measure the time? Day of the week, time of finding when people are use cab more and normal days. Absolutely great, Tharan. Uh, yes. So the purpose of focusing or creating a feature of day of the week is, as all of you have said correctly, that maybe in weekends in a certain area people go from one place to other. So let's say in Delhi, I don't know how many of you belong to Delhi. So in Delhi, if you in weekends, many millennials go to Khan Market, where lots of pubs are there, and so the destination could be anything, any place in Delhi, but lots of sorry, the source could be any place of Delhi, but lots of destination will be at Khan. And lots of people go to Connaught Place, which is again a hub in Delhi, and so lots of people go there also in weekends. So that's so that the flow of cabs changes in weekends, and the flow of cabs changes in weekdays. So in weekdays, normally people travel from their home to their workplace, maybe SEZ, maybe some IT hub, right? So that kind of places. So the cab flows changes these places. So if you can categorize based on the day of the week, you can check that why a certain people taking cab from a certain place and going to a certain place, And if they're doing it frequently, then what would be the purpose? Nandini, determining the arrival time date of package from one to other destination. Okay, so Nandini, I think you are more focused on the package delivery part, and plus uh, with the day of week only, it will be difficult for you to have that factor as a travel time. It will be more of a map thing and a place thing. But it could be a factor when once you're dealing with the package arrival time in terms of trying to find out the best path to travel from one place to other place, so that you can check that if uh, peak hours are in weekdays in morning and evening, then you avoid doing that, and if it is weekend, then you can do that, right? Okay, great. So these are the new features we have we have created with the help of one date time only, right? And we can focus on that. So we can do that weekdays also based on the week of day, and Saturday, Tuesday, Wednesday, just to get more intuition. And then we can, we do not have to. Let's leave this for now. If you want, you can add calendar also. As you can add calendar, so you just need to use one stiff F time, which is a part of daytime documentation. You can check. You just need to put, the percentile B, and it is going to give you based on the start date. Is going to give you that month. Right? So month can also be important with the same reason as you guys have already mentioned. So if the month is, let's say, if it's in India and the month is October, somewhere around October, and it's Diwali time, then most of the people may not be traveling to offices, or maybe not pubs also. And if it is some long days, let's say for schools, then most of the people may not be dropping their children to schools also. So that kind of factors come into if you have more features, right? So you can analyze on that. Now, some of the questions which you can ask with the data. So now you have data, you have months also. So one question is, which month did he get most drives? So did the drivers get more drives? Right? So the driver gets more drives on start months will be 61, first month will be 61, 105 and all. And the most drives it is going to get on 12th, which is December. And similarly, if you want to, just check the number of miles per month, you can do that with the same logic, but in terms of start, we are using cal_month, and we are just calculating month. Okay. So in terms of, if you want to do, if you do not want to check the sum, if you want to do the mean of it, you can do that. That what amount of miles it driven, the guy driven per month as a mean, you can do that. So as you can see, it's consistent 2.8, 2.8, 2.8. While in September it's 1.95. So it's 50% low in 1.95 as compared to this the highest part. So you can also check how many times the driver, how many times the driver actually open their car, or maybe the driver is on leave at that time and do not drive much Uber. So right, so all other things, when does he usually start in morning? You can start hours, you can check in morning what time it actually moves, and does he have a preferred time to start? So if that kind of analysis you can do, so you can say that so start hours is usually this part, which is 13th hour. So the guy usually starts at 13th hour, and usually starts at sometime at 19th hour, but it do not have 9 to 10 hours of the peak hours, seems to be between 12 to 5 p.m. But it do not have a specific start hours mostly. And you can see if it's 9 to 5, so that's a peak hour, and most of the people travel at that time. The peak hours. Okay, so let's all of the data analysis part is just similar to the what I have done till now. And one important thing, which is speed, which you should focus on, that you can check what if a guy starts from one point. This is interesting, right? So if a guy starts from one point and to second point destination, and in a certain amount of time, then what would be the speed of that guy to travel? Right? So by this, you can find out, does that person breaking the speed barrier? So breaking that so it's 60 miles, 48, 15, 48, 15. It's normal, but you can find, if you do this analysis, you can find maybe some trips the guy have driven really fast, maybe 100 miles per hour, and maybe in sunrise the guy have driven very slow. That also affect, and you can check that if what was the hours in which the guy have driven 15 miles and 100 miles, and based on that you can direct the driver that you should not cross 100 miles, or you should not drive that much slow if there is no congestion. Right? So I think we are end of our session. So we can. Do you have any other question? I'll share. So the thing which I'm not covering right now, so you can explore. I'm just leaving it on purpose so that you can explore this by yourself, right? So this is the same thing. There is nothing new. I just group by. There is no new function. Just group by the different more dimensions which you can explore by yourself. Anyone have any question on this? No. So yeah. Okay. Okay. So if no one have any question on this, Anand. Okay, Anand. If no one have any question on this, then I think it's time for lunch. Ritika, can you confirm that? Ritika, are you there? Okay, so let's uh, let's take lunch break now, and we will going to. This is around 2, and we will going to connect. I think 1 hour, maybe. Can you confirm? We're going to connect on 3. Right? And what we're going to cover after this? So you tell me. So we have two things to cover. What would you like to cover next? So one thing is we're going to cover the exploratory data analysis, where we are going to learn about different graphs, how we see patterns in the graph, how we can find out different correlations between values. And the second is we're going to run a supervised learning algorithm use case, which is decision tree, and we are going to build a ML model and evaluate that. So which one would you like to go next? You can write in the chat. We will share the notebook with you after this session. So we'll complete this day and we'll share the notebook with you. There's no issue in that. Second one, so Raghuvansh wants to know about uh, machine learning algorithm rather than EDA, and other people can also vote. I'll go with the majority. The second one is ML algorithm. The first is exploratory data analysis. Second one, okay, 2 vote for second one. ML algo. Okay, so everyone, I think everyone wants to do this ML algorithm creation case study. So we'll go with that after the session, right? Okay, okay. We'll go with that. Yeah. Okay, so thank you everyone. We'll meet after around 1 hour. Thank you. Hi everyone. Let me know if I'm audible. Okay. So let's get started. So as we discussed, the next 1 or 2 hours, we are going to spend the last session. We are going to spend on understanding and machine learning algorithm in detail now, and uh, we'll do a case study on that particular algorithm and understand that how we can we can complete the cycle of analyzing the data, then creating a model, then evaluating a model, and what kind of effort and knowledge goes into, right? So we'll go through that. So let me. I hope you are able to visualize my screen. It is visible to all, and let's. Okay, so so the formal definition I've already given you intuition about dysentery, right? So the formal definition of dysentery are a non-parametric supervised learning method used for classification and regression, and the goal is to create a model that predicts the value of a target variable by learning simple decision rule inferred from the data set. So why I choose to create a decision tree model rather than a lossy regression model. The reason behind that is decision tree model is more intuitive, as we have already learned, and you can actually check how the model is making less than greater than decision, or what category it should be in. These kind of decision, you can visualize that tree. Once the model is able to learn, you can visualize that tree and interpret your model, that how that model is learning. Right? So that kind of intuition or interpretability you can get only on tree-based model, and it will be difficult for you to get on a probabilistic model like naive Bayes or loss regression model. Okay? Now let's understand how exactly TD work. Right? So in the last example, if you remember that we are supposed to find out a route in which the route was age for us, right? It was age, and based on that age, you move forward, and the next leaf node you choose gender because we had only two nodes, gender and age. So similarly, but that is one thing which you are able to understand because there was only two columns, right? So, but uh, if you have, let's say, 10, 20, 30 columns, it will be difficult for you to choose which column actually more effective or more decisive, which you should choose first, then which you should choose second, and this kind of thing. Right? We can do it mathematically. Let's dive into how mathematically dysentery make or choose root node and choose a column as root node. Okay? So the first component in this scenario is entropy. Entropy is measure of randomness, right? So the measure of spread of your data. And the basic formula of entropy, as you can see here, is pi is probability, log of 2 is probability I is nothing but the data points, the probability of information gain from P1 to Pj. So how many probabilities you get. So we'll check that how you will find out probabilities of this. But the intuition behind this is if your entropy is max, in case, let's say this is the entropy, right? Let me check the pointer. So this is the entropy, right? And this is the probability is going towards 0 to 1. And if your entropy is max, so your entropy will be max if your probability is 50%, 50-50 split. So let's say you have two classes. Let's say you have two classes. Your class one is positive, your class second is negative, right? Which you're supposed to predict. And if you have 50-50 probability of going into one class, then your entropy will be maximum. One, right? Why? Because measure of randomness. This is the highest degree of randomness because 50-50 splits are there, right? But if your split is 100 and 0, if your split is 100 and 0, again, let me repeat what is split. Split is 100 is belong to one class, probability of occurring one class is 100% and probability of occurring second class is 0%. If you have this kind of probability split, then your entropy is 0. That means it's a decisive measure. You know that whatever data you are going to get, it belongs to this 100% class, right? So you are there is no randomness. There is no randomness. That's why the entropy is 0, right? So this is the basic uh, uh, properties of entropy, right? Now let's find out. Let's take an example to calculate how to calculate entropy. So we have a data point, we have a data set in which we have columns like day, outlook, temperature, humidity, wind, lateness, in which we have days, we have different data types, different rows like D1, D2, D3, these are different days. And in D1, the outlook is sunny, temperature is hot, humidity is high, and wind is weak. So this is your predictive class, right? This is the class. Play tennis is the class which you are supposed to predict. Classification problem again, right? So if in day one outlook is sunny, temperature is hot, humidity is high, wind is weak, then you can play tennis. You cannot play tennis, right? If you should not play tennis, let me put it that way. If outlook is overcast, temperature is hot, high, wind is weak, you can play tennis, right? So so you're supposed to check these four features mostly, and based on that, you're supposed to predict that should you play tennis or should you not play tennis. Okay, are you able to understand the use case, the case, the problem set which you're going to deal? You will write yes, no. Okay. Other people, only Shravya is responding. If giving response, Sakshi. Okay. Okay. Divya. Okay. So, so you are able to understand the use case, right? So this is our predictive class, which we are supposed to predict, and this is our features, right? This is our feature. Now let's calculate entropy. So you have seen the formula of entropy, right? This formula of entropy. Let's deal with it. So if because it's a sum, as you can see, it's a sum. If I expand this, it will be the probability of positive, like means yes, positive is yes, plus is yes, negative is no. The probability, the minus probability of positive, log of probability of positive, minus probability of negative, log of probability of negative, right? So what is the probability of positive? Let's find out that. So how many positive are there out of? So there are 14 occurrences of data, right? 14 data points. How many positives are there? Is it, just let me know if whatever I have written in the PPT is correct. So 9 are positive according to me. What do you think? It is, right? Okay. And 5 are negative, right? No are 5. So you are able to find out the probability, which is 9 by 40, 5 by 40 for positive and negative, which is this part, right? Now you are supposed to find out the entropy. You just need to put this. You're able to find out this. You just need to put this in this log. So just remember that this is base 2 log, right? And you are then, after putting this, you are able to find out your entropy of 0.9, right? Now, in case first, your entropy is 0.94. So if your entropy is greater than 99%, so what would be the case? If your entropy is greater than 99%, then your entropy will be if your probability is greater than 99%, then your entropy will be 0.0805. If your probability is 50-50, your entropy is 1. You know why this is? I've explained earlier the basic property of this. 50% probability of having positive, 50% probability of having negative, right? This is randomness. This is the maximum randomness you can get in two classes. It can go either way, right? So, uh, so uh, That's why the entropy is maximum, which is 1, right? And the third case is again, if it is biased toward one class, so 100% probability of one class. Let's say that all these classes are yes, all these classes are maybe no. In this case, let's say all these classes are no, then y negative would be 100%, and if all these classes are yes, then y positive will be 100%. Right? If any of this case, then the entropy will be 0. That means there is no randomness. There is no randomness in the data. So once you are able to find out entropy, which is 0.94, then so what will be the next thing you're supposed to find? So the next thing you're supposed to find out is information gain. So how you find out information gain? Let's check that. So, so the first thing, you have seen that this is first column, second column, third column. So you are supposed to choose one of this column and find out that by using which column you are getting maximum information, right? What is information? Information is something which can be, if more information you will get, that is more decisive you can choose, right? More decisive column it is, and you can choose the maximum decisive column first and then drill down to the next column, right? Like we did in age and gender. Okay, so we have chosen Outlook at first, and Outlook have 3 categories: sunny, overcast, rainy, right? Sunny, overcast, rainy. So we have choose 3 categories: sunny, overcast, rainy. Now, we have divided our whole data in these 3 categories. If Outlook is sunny, these are the temperature, these are the humidity, these are the wind, right? And these are the prediction. If Outlook is overcast, these are the data, these are the prediction. If Outlook is rainy, these are the data and these are the prediction. Right? Now, you have to find out entropy for this particular class. So what will be the entropy of this particular class? It is going to be 0.97. Right? You can if you want, you can try to run that. Just put the same formula we have written. So try to find out positive and negative. In this case, the probability of negative is 3 by 5, and the probability of positive is the probability of negative is 3 by 5, the probability of positive is 2 by 5. Similarly, the probability of positive is 100%, right? All yes. And same for this. You're supposed to find out the probability of negative and positive. Put that in formula, you will get this value. Now you have 3, because of these 3 categories, you have 3 different entropy, right? Now you're supposed to find out the average of that entropy, average of entropy, so that you can use this one value in your final formula of information, right? So give me a sec. I'm sorry for that. So you can choose 2 things. One is average entropy, and you can choose weighted entropy also. So we'll show you what is weighted entropy. Okay. Now this is final entropy on the formula which we use for entropy, and this is the average, the weighted entropy formula. So this is the weighted entropy formula. So this is the entropy, right? For one data set. This is one data set. This is one D, right? And this is the entropy for final, or the whole data set or whole sample. And this is the weight. What is weight? Weight is nothing but how many columns which are you considering to find out that entropy, right? Which is in this case 5 by 12 out of 14. Total number of columns of 14, but we have considered 5. Total number of columns of 14, but we have considered 5 for this entropy. Total number of columns of 14, but we have considered 5. Right? What is it? Let me go back, and if you can see, we have 5 here, we have 4 here, and we have 5 here. Right? This is the same thing. We have 5, we have 4, and we have 5. Right? Out of total number of occurrences. Right? Simple problem. So once you're able to find entropy for whole Outlook column, right, then you're supposed to find out the information gain. The information gain is nothing but the entropy the entropy which we're able to find first, which is 0.96, I believe, and then the entropy based on this particular outlook column, right, which is AK, and which is okay. So it was 0.94. So 0.94 minus 0.69 is something which is information gain for you. Okay? So information gain is 0.46. Right now, information gain for outlook is 0.46. But as you know that we have many other columns. We have temperature, humidity, windy. So if you do not choose outlook as first root and you choose temperature for first root, then again you have to do the same thing if you do it manually, right? So obviously you're not going to do it manually. And so similarly, we are going to find information gain for outlook, for humidity, for temperature. And so for temperature, we have 0.029, for humidity 159. So if you'll find all other column information gain, then you will get that the highest information gain you're getting is from outlook. So if you choose outlook as first root or the root of your tree, then you'll get the highest information gain to drill down on other columns, right? So what is our root node now? Everyone, which is is supposed to be a root node after this? Outlook, sugar, correct? And why? Can you just? I'm just confirming that you guys are able to understand what I'm trying to explain. Why we choose Outlook as our root node? It has more information gain. Correct, Akash. It has more information gain as compared to the humidity and temperature one. Correct. So this is how your decision tree make choose your root node and then drill down afterwards. Right. Then you have to do the same thing again and again. So first you are able to find Outlook as your root node. Then you choose this. Then again you have to do same thing. Right. Same thing you have to repeat, and whatever the information gain, maximum information gain you are getting from this port, this slide you're going to choose that as a node and then drill down. Same. Now this is this is because this is 4 positive and 0 negative, which is 100%. Then the entropy is maximum, which is so entropy is 0, which is low entropy, and that's why there is no randomness. That means we have make decision here. So you do not have to create more trees under this, right? Because in if outlook, so let's see how it goes. If you have a new data, you check outlook. If outlook is overcast, you play tennis. You do not have to take a further decision now, right? If you have rain, then obviously there are 2 negative, 3 positive, then you have to take a further decision so that you can go to a pure node. So this is called pure node, right? Where you do not have to go further to make decision. You have taken decision at this point only. Okay? So pure node, P-U-R-E, pure node. So let's conclude how decision tree algorithm work. First, find the entropy of your parent with prediction class. Find information gain with respect to all features. Select root node based on the max of information gain. Right? With selection of root node, we have to divide the data set into D1, D2, D3. So data set will get divided as we have seen earlier. And based on the child node, we are supposed to repeat the step 2 again, and then again find not exactly root node, but the new leaf node, after which you can go further. And then until you reach the pure node, and the tree cannot grow more than that, or you have lack of data, you can stop. Right? So if you want to do it manually, you can do like this. All right. Now, some key parameters which you should consider while creating or handling decision tree algorithm. One is minimum samples for a node split. Right? So, how many samples once you reach to a node, then how many samples you should split towards node? The reason behind that is, let's say we have just 10 data points, right? And if our decision tree is able to create 10 10 nodes at last leaf, right? At last branch, then, and every node is going to make one decision, right? That will go, that will, so the decision tree will be out of your control, and you may fall into a thing called overfitting, right? Because every node is going to make a decision on a minute level, and you're not going to get a generic sense of decision making through your node, right? So that's a node split. We're going to go through this when we'll do the case study, right? And the second thing is maximum depth of tree. So what is maximum depth of tree? It is how many, till what level you want to go in depth. Right? So maybe you have 4 columns, but you just want to go to 3 columns. Right? You do not want to go with 4 or 5 or 6 columns. It again, for the same reason, if you go to the last column, then maybe in last column you have only 2 values, and 2 values will going to give you decision like true and false. Then maybe in the new data you may not have that good decision making capability of your algorithm, right? So because your algorithm is biased now and overfitted, right? So do you guys understand what is overfitting, or should I explain? You can write in the chat. Okay, Arishi. So let me open my code. Okay, are you able to see whiteboard? Okay. So let me take this. So let's say you have data, right? You have a certain amount of data in which you are trying to converge your model, right? So you have, let's say you have data like, mm, let's say we will take the same example, right, of play tennis. And in this example, if you have certain features, right, certain features, but if you have data which is just all yes, so most of the times you have yes, and in, let's say you have data point which is 10, and out of that 9 is yes and 1 is no, right? So in a way your whole data set is biased. In a way your whole data set is biased, right? So if you're going to train your model, your ML model, and feed this data to your ML model and try to find out the prediction of it. If your ML model randomly predict, let's say if your ML model randomly predict yes, right? So what would be the probability of it getting right? So what would be the accuracy of your model? Anyone focus on this? If you have 9 yes, 1 no in your data, and if your ML model have not learned anything, just randomly predict yes, what will be the accuracy of your model? Anyone? 10%? Okay, 90%. Correct. So it's 90%. Arushi, why is it 90%? Because 90% of the time the model have seen yes in the data, and only 10% of the time, if the model have given no, then it could be 10%. So even if model have not learned anything, right? Even if model have not learned anything, but still the model is able to produce 90% of accuracy. Why? Because the model, the data set is biased. The data set is biased towards yes, right? So this is what your model is getting overfit. This is one example of overfit, right? The second example of overfit is, let me clear this. You are able to understand this? Do you have any question on this? You can just write. Okay, I'll clear this then. So if you, so the second example of this is, let's say you have seen, okay, a sec. You have seen the graph of classification, right, which I've showed you, which makes a decision tree. So let's say we have certain data points here, right, and we have certain data points here. Now this particular class, let's say this is positive class, and this is negative class, right? These are two classes, right? Now, if I have to take, I have to create a decision boundary between them. I have to create a decision boundary between them. Now, if I want to, if I want to provide 100% accuracy, at least 100% accuracy, or maybe 99% accuracy. So what should I do is I should create a decision boundary something like this. This is separating these two classes perfectly. Am I right? Yes, correct. Gautam, data is unbiased if 50% and 50% both are 50-50%, then it is unbiased. So we have representation of both classes equally in the data. So Murli, if train accuracy greater than test accuracy, is called as overfitting. So Murli, it obviously it is if train accuracy is greater than test accuracy, but how much greater? That's the question, right? So let's say if the train accuracy is if the train accuracy is 85%, and if your test accuracy is 84.5%, then it's not an overfit. It's not an overfit. But if your train accuracy is, let's say, 90%, and when you do test accuracy, it is coming around, let's say, 75%. It's a drop of 15%. It's a big drop. That you can consider as overfit, right? And so this is just a way to check if it is overfitting based on the test and train accuracy. But the intuition behind that is how it is overfitting. So if your model is going to see some data like this, what your model will going to do? Your model is going to not going to create a straight line. The model is going to create something like this. If, right, and if model is going to create something like this, and if I introduce a new data, somewhere here, the model will fail, right? So what will be the best way to model to convert this is, this. So the best way for a model to converge is not giving you the bended line like this. It's better to give you some straight line which is fitted properly, right? To classify some decision boundary, as I've used this term earlier, some decision boundary which is able to fit properly, but may not give you 100% accuracy or 99% accuracy. It may give you 90% accuracy. But the best part is when you introduce a new data to this, let's say I have introduced a new data to this somewhere here, right? Then this will belong to a right class, right? Right prediction. So your model will not fail when you put it in production, right? So your model is more towards generality rather than biasness. It has created a generic decision maker model for this particular domain. All right. So that is so we should avoid overfitting, right? Maybe by providing more data. Absolutely, Gautam, correct. So we should avoid overfitting. Overfitting we should not do. We should check if our model is getting overfit. How we should avoid? First, we should avoid we can provide more data which have more coverage of variance of data. Second, we can check if we have, as I've shown, the distribution sample distribution of prediction is not correct, which is 90-10, right? We do not want that biasness. Third, you can check if your model hyperparameter can change that. So hyperparameter is, I'll show you what is hyperparameter. Hyperparameter is nothing but some constant values which you take in your equation of in your model equation. Right? So you can deal with hyperparameters. Check if your model is still overfitting. If it is, then check for sample distribution. If it is biased, if it is, then you can go with something called upsampling, which is going to create uh, some more data in this particular class, right? And ultimately going to balance out, maybe make this 50-50, right? And obviously, if you have option to add more data, then that is going to be the best option. Right? But normally, whatever data you have, generally you do not have more options to get more data. Okay, so these kind of things you can do, right? Okay. Do you have any question on this? Should I clear? So, multicollinearity is entirely different thing. Multicollinearity is something which, when you're dealing with, let's say, logistic regression kind of model. So the basic assumption of logistic regression is you do not. So your class, all the variable, all the features which you have are independent to each other. What is independent to each other means? It means you do not. So let's say you have a column called salary, and you have a column called age, and you should not have any collinearity or correlation between salary and age. So let's say if this is salary, this is age, then there should not be any relationship, or maybe salary is increasing or age is increasing within your data. The only correlation it should consider is uh, with your prediction class. So let's say you have prediction class, so you should have correlation with the prediction class and with the other features, which is salary or age. Right? The reason behind that, why it should not be the case, and why there should not be multicollinearity between them is, uh, if there are lots of columns, right? If salary and age is one example, let's say there are other columns which also having correlation between them rather than the prediction class, then maybe these 2 or 3 columns which have correlation can dominate your model, and your model will understand that these kind of features uh, have more weights in making prediction rather than because it combines together each other, and if it gives enough weight for these 2 columns, then the combined weight will be more, right? And because it is influencing each other. Yes, salary and expense are related. It must be not considered. So you are supposed to check that if there is multiple linearity in your model, then the best thing is drop the. Okay, what you can do if you have multiple linearity, so you can do is you can uh, you can combine those 2 columns. Okay? Combine those 2 columns in a mathematical equation or something like, just uh, create a weight, let's say 0.2 of salary and plus 0.4 of age, plus 0.5 of expense, and you're going to create a new feature based on your assumption. So your assumption is that 20% importance to salary, 40% importance to age, 50% importance to expense, and then you created a new feature, which is salary underscore age underscore expense. Right now you're going to have only one column. You're going to drop these three columns from your data. Right, then there will be no multicollinearity exists, because you have taken in account of all these three columns, but created a new one. All right. Okay. So yeah, so that is also I was talking about the upsampling part, right? So the upsampling, this part, the upsampling will give you the 50% part, and you can also do downsampling if you want. So there are different concepts of SMOTE. You can check if you want SMOTE. This is a method to do upsampling. You know, explore more of this. Okay, let me clear this. Let's go back to our slide. Okay. Now, as I've already explained, the tree-based model, which is decision tree model, and the linear model, which is loss regression model. What are the difference between them, and which one you should use in what use cases? So let's say if you have if the relationship between dependent and independent variable is well approximated by a linear model, will be outperformed by tree-based model. So tree-based model do not have issue with the multicollinearity. If you have multicollinearity in it, the tree-based model will work fine. It do not have the pre-assumption of it. If you need to build a model which is easy to explain, as I've already explained to you that decision tree model is easy to explain to others, you can show tree that how the model is making decision. Then you should use tree-based model rather than linear models. And let me give you an insight from industry that nowadays it is getting very important to have a model which you can interpret, which you can show to others and show that how that model is making decision. The reason behind that, otherwise the model will be a black box for senior management and stakeholders. And if in future the model goes wrong, then no one will be there to point out the mistakes because it's a black box. So wherever you can, try to choose a tree-based model rather than linear models or probabilistic models. Probabilistic models also can work. It based on the occurrences, but it's just that how much interpretability you want. All right. Now, if there is a high non-linearity and complex relationship between dependent and independent variables, the tree-based model will outperform a classical regression model. So this is the sample code. We'll go through that also in detail. But there's a different library called sklearn, scikit-learn, and you are supposed to choose tree, which is all the tree-based model comes into this category, and then you choose a decision tree classifier if it's a classifier problem, and you choose decision tree regressor if it is a regression problem. Then you choose some kind of metrics, which is accuracy score, if you want to check accuracy score for your model. And then you initialize your model in any object, any name, whatever you want to give it to this, and then you just do fit, right? So this is the only part which is building a machine learning model, right? So this is just 2 line of code, as you can see. So whatever you are learning, whatever you are understanding through this workshop and in future also, whatever course you're going to do after that, everything what you're going to learn will be combined in these 2 lines most of the time. But obviously, it's not that easy, because these 2 lines will obviously fit your model in computer language. But is your model good enough to use? So you are going to be the person who is going to make decision that if that model is good enough to use. Yes, Arushi, I'll share these slides with you. After the presentation, I'll share this slide with NH Electronics, and they will share to all your, maybe in Common Drive and maybe on your mails, they will do that. Okay. So there's one more. So when you dive in this entry, there's one more option. One entropy I've explained. There's one more option called Gini index. This is same. Just as you can see that we are just trying to find out probability on PJ, and in this the PJ log 2 PJ we are using, but for Gini index PJ square 1 minus PJ square we are using. So just a change of formula, but ultimately you're going to get the same, nearly the same output, right? But a different path to go in, right? Okay, so we have reached end of the slide. After that, we'll jump on to the case study, hands-on. If you have any question on this, feel free to ask. Anyone? So, are you able to understand decision tree? If I ask you now, if I give you a data point, data set, and if I ask you find out the root node for me, are you able to do that? I'm looking for some yeses. No? Okay. At least one yes. So do you want me to, if people are not able to understand, do you want me to repeat that? Okay, Arushi, do you want me to repeat? Okay. Post IG part. Post IG part, then nothing left in post IG part, Arushi. I'll repeat it. Other people, if you can tell me that, do you want me to repeat, or are you able to understand that how to find entropy and information gain? Gautam and other people who have, yes, sir, please repeat. Okay. So you can ask that. Guys, I do not want you to leave this session, at least what I'm entropy, I understand. Okay. So I do not want you to leave this session, at least what I'm explaining. You should at least learn that much, uh, and cement at least that knowledge, right? So let me repeat. No issue. Let me go back to the mathematical part of it. You are able to understand multicollinearity, Murli, do lead to overfit if you are using linear models like logistic regression or linear regression. Then it may lead to overfit. But if you are using tree-based model or ensemble models or probabilistic models or SPM model, then it may not. It will not going to affect on your end result. Okay, so do you want me to repeat from this slide? It is still, I believe, 4:30 or 5. Ritika can confirm.
Yeah, it's up to 5.
Okay. This slide? This one? Yes. Okay. So till this point, what we are trying to do is we are trying to find out entropy based on this split. So we have split. So see, this is entropy for whole data. Right? The entropy for whole data is 0.94. Correct? Now let's find out entropy. Let's find out entropy where we have split based on one column, which is outlook, sunny, overcast, rainy, and then we are going to find out entropy for this set, and for this set. Okay? Open this in the presentation mode. Okay. For this set, and this set. So we have 3 entropy now. Right? So we have 1 entropy which is 0.94, and now we have 3 entropy, but based on this split. Right? So what we can do, we are supposed to find out the weighted entropy of this. Weighted entropy of this. Right? Let's go to find out weighted entropy. Now, the formula for whole entropy you must have seen, which is 0.94 was the output. Now the weighted entropy part is, this is same. This is same, which I've seen earlier. This is the different part. What is the different part? The different part is the data set, the size of the data set, which is 14, the total size of the data set, which is 14, out of the size of the data sample, which is 5, right? This is the data sample, which is 5. Which part? This part. This is 5, right? This is 4. Remember, this is 5. This is 4, size of it. And right now, so this is the part which is 14, right? And this is the sample part which is 5. So what we're trying to do, we are creating a weight which is 5 by 14 multiplied by 0.97, which is 0.97. 0.97 is nothing but the entropy of this. Okay? So weight multiplied by entropy of this particular data set. Right? So what we are going to get from this, we are going to get the entropy on outlook. Earlier we were able to find the entropy of whole data set without making any decision. Now this is entropy on outlook only. Right? Now if entropy of outlook, so this is 4 by 14 multiplied by 0. 0 is this, and then this is going to be 5 by 14 multiplied by 0.97. Okay? 5 by 14 multiplied by 0.97. So our entropy for outlook is 0.692. Now what we're trying to find? We're trying to find out is when we took entropy of whole data set, and then when we took entropy of only, what is the difference? Right? So entropy of whole data set and entropy of outlook. What is difference is 0.94 minus 0.69 is equal to 0.246. This becomes our information gain. So we are getting this much information if we choose outlook. Right? Similarly, if you do the same thing for others, humidity and temperature, the same exercise, then you will get different information gain. So we calculated 0.94 here. Give me this part. Gautam? Yeah, this one. Right. So this is the entropy of whole data set. You have not selected any column here, right? No column have been selected here. So this is the whole data set entropy. Now entropy for outlook, then whole data set entropy minus outlook entropy, you will get information gain. Simple. Whole data set entropy minus column entropy, you get information gain. And you are supposed to do it for all the features. And whatever the maximum entropy and maximum information gain you're going to get, you'll choose that as a root node and then do it further for all other nodes. Once you select a node, you're not supposed to choose that node again and again. Right? So you just remove that node. Okay. Great. Okay. So I hope at least now, can we take a quick look to root splitting also? Root splitting, we can. This is the root splitting. Okay, so what we are doing, we have selected outlook, right? Now based on the outlook, we have 3 categories: sunny, overcast, and rain. In sunny, we have this much data point: D1, D2, D8, whatever data point have sunny as outlook. Out of that, we have 2 positive, 3 negative, and now again you have to do the same thing on sunny and find out the information gain. Like you can see 0.970, 0.570 and all. So you are going to choose humidity as the second node here. And this is the pure node because there is no negative, only positive. So you can choose yes here directly. And same you're supposed to do it for D. All right. Okay. So let's I hope now at least if someone asks you, and it's you know frequently occur question in interviews. If you are able to, if someone asks you how dysentery work, just do not give you the definition. Try to explain through entropy, through information gain. Try to explain how information gain, how you choose root node, and it will be much more beneficial for you to convert that interview. The more you go in depth, the more better will be for you. Okay. So now what? So our case study now, right? Uh, do you want 10 minutes or 5 minutes break, or should I continue? You can write in the chat. Okay, Arushi. Okay, so there are one break, one break, break. Okay, so many people are asking for break. I'm sorry, Arushi, we have to take break. We should go with the majority. So let's take 10 minutes break. We'll catch up back at 4, exact 4, 9 minutes we have, right? Then we'll start with our case study. Right? Okay. Okay. So let's get started with our case study now. And so what, am I audible to all? Just confirm on the chat. I'm audible. Yes, okay. Fine. Uh, so today's case study is about wine quality prediction. There's a probability that many of you or many of you may not know the variance, different types of wines and the quality of wines, how to check that or not. But it's okay because as a data scientist, many of the times you do not know about the domain, right? So at that point of time, what you're supposed to do, you're supposed to ask someone or ask a domain expert and get that domain knowledge for you, so that you can do better, decision making or prediction with your data. So in this case, so we are not analyzing our data right now. So we're just building our decision tree machine learning model. So that's why right now it is not that important. But if you're doing EDA, expert data analysis, then it is important to have that domain knowledge, so that you'll ask the right question, right? Okay. So let me give you some context on this data set. This data set is related to red variant of Portuguese Vinho Verde. Due to privacy and logistic issue, only physiochemical inputs and sensory output variables are available. There is no data about grapes types, wine brand, wine selling price, etc. etc. So, what are the data which we have? So, or if you want to download the data set, you can download from this URL. Right. So I'm going to share this Jupyter notebook with you guys. So at that time, you can fetch and run this notebook and experiment on your own. So the problem set is wine quality prediction. Here we will apply a method of assessing wine quality using a decision tree and test it against the wine quality data set from the UC machine learning repository. The wine dataset is a classic and very easy multi-class classification dataset. So what we're supposed to do is we're supposed to find out, is our machine learning model making good prediction with with the dataset, and going to compare that with the test set which is from UC Irvine machine learning report. Right. Number of instances, it have red wine which is 1599 and white wine which is 4898. What are the features? So what are the columns, right? We are supposed to use in a machine learning model. That is, fixed acidity is one feature, volatile acidity, citric acid, residual sugar, chloride, free sulfur. So all these are chemical, names and size of that compound, density, pH, and all the properties of the wine. So for you and me, maybe it will not make much sense, but for machine learning algorithm, it will, and we'll just find out how. Okay, is there any missing attributes? No. So our data is fairly clean. We do not have to handle null values here. So if you want to dive more into the description of attributes, so what is fixed acidity? Acidity is most acid involved with wine or fixed or non-volatile do not evaporate readily. Similarly, for what is citric acid, residual sugar. The residual sugar is the amount of sugar remaining after fermentation stops, right? So again, so this may not make much sense for you and me because we do not have that expertise in making wines. But the people who is in wine industry, maybe if data scientists show them this data and they say, oh, so residual sugar should be more, which makes a wine better, and in this particular brand the residual sugar is low, so that's why the wine is not that great. That kind of insights, useful insights can be fetched for the people who uh, love to see good wine or love to drink good wine. Okay, what are the things which we are importing? These two things you already know, right? I've showed you this in the slide. NumPy is imported 2 times. It should not be. And Seaborn is a library which you can use for creating graphs, right? And this is model selection part, which is from sklearn library. As you can see, the dysentery classifier also from sklearn library, but the subclass is different. sklearn dot model selection. Earlier it was tree. So a tree have all the tree based model. The model selection have the all the function which you can use for train and test split and maybe for evaluation or all this stuff. And it is again okay. So it happened to that. So and in metrics part, sklearn metrics, you can choose your evaluation metrics. And is not able to enter meeting now. It is that host has to let him in. Ritika, can you let the people in who is in lobby? Ritika?
Yeah, done.
And so all these functions are nothing but your evaluation metrics report functions, right? So model accuracy is one, F1 score is second. We're going to go through today only what is F1 score, what is recall, what is precision, what is the confusion matrix. And let's this is how our data looks like. Again, it is not going to make any sense because it's just numeric values. So what are the data we have? We have all the float data types, so we do not have to handle categorical value. Remember, I explained that if you have categories, then you are supposed to handle categorical value. We do not have that in this use case. All are floats and int, so we do not have to spend time on doing that. Some statistical analysis, descriptive statistics analysis you can do using again the describe which I've explained earlier, right? It is not going to make much sense right now, so we are going to jump on the analysis part and then the machine learning part. So let's say this is the quality of wine, right? So the quality of wine range from 3. So let's consider it as review star or the star, right? Or the rank, not rank, or the grade, right? So this is a third 3-star wine. This is 8-star wine, right? So the 8-star wine is considered as the best wine, I believe this is the case, and the 3-star wine considered as the low wine, right? So as you can see the quality 3-star to 8-star. Now what is the problem? So I have explained one biasness problem earlier. Do you think that biasness problem is happening here also? Anyone? You can write a chat. I've given an example of 90-10 overfit example earlier. Do you see the same problem here? No, Arushi? Why? What about other people? Do you also not see any biasness or undersampling of data? You understand this graph, right? This graph is yes. So 5 and 6 have lots of data, but we have 1, 2, 3. We have 6 classes, right? So there will be biasness toward 5 and 6. What about 3? The representation of 3 is not good enough in making decisions, right? The representation of 8 is also not good enough, right? So there is some level of biasness, but not the biasness which I've explained. The 90-10% biasness is not there, but there are some level of biasness, right? And you should handle that also. Otherwise, what will happen is most of the prediction will be in this range only. Okay? And if your wine belongs to third category of your wine is very high quality wine, which is eighth category, then chances are that dysentery will not be going to make much accurate decision in predicting eighth category. Okay? So one way, obviously you can upsample it, but one other way, because it's a quality prediction part. One other way is you can combine these. Let's say because it's three, because it's just a category, it's three. You can combine 3 to 4 and 8 to 7. Then you will have four categories, which is 4, 5, 6, and 7, right? And these low categories will be uh, absorbed in seventh and fourth category. Right? So overall distribution will be better. So if if you want to check the distribution of acidity, even though it is not going to make sense right now, but if you want to check the distribution of acidity, then you can check that this is the distribution of the acidity where this is normally distributed. So most of the wines have 6 to around 9 fixed acidity, right? And if you feel that if it is not this good, if the distribution is not normal, then you can consider that this is skewed at left or right, and lots of data is at one side, and maybe that may affect on your end result. So you do some kind of logarithmic uh, processing to make it normal. Okay? Uh, So the distribution, if you have, again, let me repeat this, it may get confused. If you have distribution of your data, which is, let me take whiteboard again to explain this basic. Okay, so let's say if you have distribution of data, something like this. This is called, some people call it normal distribution of your data. Let's say the data is fixed acidity, which we just said. Let's check. Right? Normal distribution, some call it Gaussian distribution, right? You can also call it this particular curve as bell curve, whatever you like, right? Now, the important part is not the name. The important part is what this distribution indicates. If this distribution is normal distribution, then this part and this part are equal. If it is perfectly normal distribution, and this is going to be the mean, whatever the value of the mean is, right? This is going to be the mean. So what it says is if you move one standard deviation towards left and one standard deviation, one SD towards right, then you are going to cover around 66% of your data. 66.6%, I believe, if I'm not wrong. Right? Something like this. 66 or 66.6% of your data. If you're going to go next standard deviation, both sides. Let me change the color of it. Next standard deviation, both sides. Then you are going to cover around 95% of it, right? And the third, which, so right now we have done 2 SD, 2 standard deviation, both side. If you go to third standard deviation, then your data coverage will be 99%, around 99%. So this is a standard distribution of data, right? Now, if your data distribution looks something like this, this is not a standard distribution, right? This is skewed. The data is skewed. So what that indicate is the data, the most of the data, let's say the 99% of the data ended in this particular part. So this is called left skewed. And if your data, so the similar graph, if your data distribution looks something like this, right? Then this is the most of the data, your data occurs at the right side of it, then it is called right skewed. And why left skewed and right skewed are not good? The reason behind that is because your data distribution is not normal, and you are creating some kind of biasness toward this area, right? And most of the, so what it indicates is, let's say this is fixed acidity, right? This is fixed acidity, and if this fixed acidity impact on the quality of wine, right? So most of the quality of wine which belongs to this particular area, let's say it's from 0 to 9, or then this is 15, belong to 0 to 9, have more representation in your model. Why? Because 90% of the data belong to this particular range. So if your, let's say, category, if your category 3, or so let's say if your category 4 wine have range of fixed acidity 0 to 9, then the representation of category 4 will be 90%. Whatever the amount of data occur here, let's say 90% or 80%, whatever. Right? So it again creates a biasness in your model, and your model will be more lean towards this particular area and this particular category. What you want? How to avoid this? You want normally distributed data, right? If you do not have normal distributed data, what you can do, you can make it approximate normal distribution. So there is a concept called okay. So there is a concept called I think box Cox, right? So this is just a fancy name. Let's think it like a way that you just make this particular data point and find out the logarithmic. Do the log of this data point, find out the logarithmic of this data. Let's say df of that particular column, which is acid, right? And do the log of it, and you're going to get approximate normal distribution. Approximate normal distribution. So obviously, it is not going to, you're not going to change data. Otherwise, you're going to corrupt that data. You don't want that. So you're going to do logarithmic of that particular data, and when you do that, then it will bend towards normal. It is not going to be perfectly normal, but it will bend towards normal. So the influence of that part of the data will be less on your model. So that one measure which you can take if you have if you do not have a normal distributor or skewed left skewed or right skewed distributed data. Correct? Bias have I explained. Bias is nothing but, let's say, uh, let me give you an example. So let me give you a cricketing example first. Let's say right now India and Australia match is going on, right? All the umpires, are from Australia, because Indian umpires and other umpires cannot travel now. Now, if all the umpires are an Australian, so on the moral ground, they should not be biased, right? But there are a high number of chances that Australian umpires can be biased toward Australia. So maybe in a place where we have maybe in a place where they can bend some rule, for Australian team to win. Maybe they will going to do. I'm just assuming it. I'm not saying that they will, but I'm just assuming it that if they have some biasness toward Australian team, they may bend some rule to make Australian team. So that is a simple term called bias, right? Now, how that biasness is coming in data analytics or machine learning. The same example which I have given you earlier. So if you have representation of 90% of your data, which is, let's say in this case, for wine case, let's say 5 star, 5 star, 90% data you have, 10% of data belongs to uh, 6 star, right? Now, when your model will going to learn, do you think your model will be biased towards 90% because it has seen more of a 90% kind of feature rather than 10% kind of feature? It have learned more about 90%. So model can be biased toward 90%. Murali? Right. So that's right. So that's one example is this. So other example is in any country where whatever the, I'm diving into controversial topic. So in whatever country, whoever is majority, let's say in some Western countries, if majority is Christian, they will going to force uh, Christian based rule, right? And they will have holidays uh, on Thanksgiving. They will have holidays on Christmas and all this stuff. Whatever the Christian festival is, right? And if you go in some Muslim-dominated company, they will have a big festival and holidays on, on Eid, Bakrid, and all these festivals. Similarly, for India, you will have uh, more festival or more enjoyment maybe on the places where Hindu are more, or places where Punjabis are more. They will celebrate their festival and all. So it's all about the biasness. They are biased towards one majority. Similarly, we have majority of 90% in the model, so they're biased towards this majority and not towards the 10%. Okay, let me clear this. Do you have any other question? Okay, thank you. Let's move forward then. Uh, okay, we have covered this question. Now let's jump on to the correlation part, right? So we have learned about multicollinearity. Let's learn about how to find out the correlation, right? So this is a simple heat map. How to create a heat map? Let's first figure that out. So this is SNS is a library which we have imported earlier. And just use heat map and give wine df, which is our data frame, and just use correlation. So what it gives you, it is going to give you a correlation matrix, right? A 2D array which have correlation between all the columns, and the heat map is going to represent that, right? So this is just a yellow, green, blue, C map, a color map, and all other things are just the alignment of the graph, right? And then you are supposed to do plot dot show to show that plot. Uh, Now let's see how we can learn how what kind of insights we can get from this heat map, right? In terms of collinearity, or in terms of linearity. So fixed acidity, right? Do you think so? Let me explain what this is. If the value is minus, if the value is yellow first and the value is towards minus, then there is negative correlation. If the value is toward positive and the color is blue, then this is positive correlation. Higher the value, more positive correlation. Lower the value, more negative correlation. Now, tell me, do you understand what is positive correlation and what is negative correlation? The people who do not understand, please write on the chat. I'll explain. If no one is going to write that they are, that I'll assume that you understand. Right? Correct. When y increase, x increase, that is positive correlation. But when y increase, x decrease, that is negative correlation. Correct, Gautam. Absolutely. So, so I assume that everyone knows about correlation. Now tell me. I've shown you how to check the value of positive and negative. Now tell me, what are the factors? What are the columns which have positive correlation and what are the columns which have negative correlation? Anyone? No? What about this? Is it positive correlated with volatile acidity? You want me to? Okay. Is it visible now? What about this part? Fixed acidity versus volatile acidity. Anyone? Is it positively correlated, negatively correlated? Negatively correlated. Correct. Is it highly negatively correlated or just average negatively correlated? Average, right? So why? So the basic structure, if you want to segregate the correlation between multiple values. So the basic structure or basic framework is if you have correlation value which is greater than 0.75 in positive or negative, then you will have strong positive or negative correlation. If you have correlation value somewhere around 0.25 till 0.75 positive negative, then you have average positive negative correlation. And then if you have less than 0.25 positive negative, then you have weak correlation, and if you have zero, obviously you have no correlation. Right? So what are the strong correlation we have? So the strong correlation we have, as you can see, we have fixed acidity and density, which is quite good, right? Average correlation, at least you can say, is 0.67. Do we have any strong correlation in this whole data, negative or positive? Do we have? No, no, right? Okay, so only Gautam is replying on the chat. What about other people? I understand it's evening, cold evening, especially in north. Please don't sleep. Everyone, clinical acidity have positive correlation. True. Uh, Fixed acidity and clinical citric acid. Sorry, citric acid. Yeah, that is positive correlation. What about other people? Only two people are active. Gautam and R.A. Murli. Only Murli and Gautam are active. What about other people? Just write, everyone write yes or something in the chat. Just one character. 2, 3. I just want to see who are sleeping and who are not. 7, 8, 9, 10, 11, 12, 13. No one after Fatima. All we have only 13 people now on the 14. We have around 30 people, I believe. 15. People don't sleep. 15 people are, I think 50% people are sleeping, 50% are not. We are on the last 30 minutes now. Wake up. Okay. Okay. So the people who have written yes, please write something. If you're not able to understand, ask in the chat. Then only you'll able to understand. Otherwise, it will be waste of the time of yours, right? So yeah, so we have, so that's how you try to find out correlation between different values. So why correlation is important? The reason behind that is if you feel that fixed acidity is correlated with density, as I've explained earlier, and you are dealing with something, some type of algorithm which affect if there is collinearity between independent variables, then it could be an issue. So you can deal with these kind of features. Now, second thing is if you feel that there is correlation between acidity and the output value, then you can directly see the prediction between your values, right? So the quality of, as you can see, the quality. Uh, if you want to see the quality and other correlation, do you see any positive correlation with the quality? Because you're supposed to predict quality, right? Just focus on this part. Yes, yes, we will do feature extraction if you feel that two columns are collinear with each other and affect your algorithm. So we have positive correlated with so alcohol is positively correlated with quality. So if it seems like if there's more alcohol in the wine, then the quality of wine will get increased. But apart from that, I do not see any other positive or major negative correlation. There is some slight average correlation with volatile acidity also. So if you can say that if the volatile acidity is more, the quality of wine will be less. I mean the degrade. Right? So that kind of answers you can get from correlation. Right? Okay. Now, so what I've said earlier that we are going to merge some quality values, which is 7 and 8 together, combine 3 and 4 with 5, so that we have only 3 levels. So we have now only 3 levels. One is 5, one is 6, and one is 7. We have combined 8, 7, 3, 4, and 4, 5. All right. So now we have 3 values to predict. Now this is the part where we start splitting our data to create a model. One is the first part you're supposed to do split, as people already explained. Some of the people already written in the chat that you use test set to have your accuracy, to check your accuracy, and check if your data is getting over fitted or underfitted. So the two, you can do it in manually also, but if you do not want to do that, then there is a function called train and test split. You are just supposed to give your df drop quality, because it is going to go in train set. It is going to go in train set, but separately, not the part of your features. And this is something which you're supposed to give, which is how much data, how much percent of data you want in test size. So let's say you have 100 data points, right? And you want a split. So if you put 0.25 in test size, that means 25% of your data out of 100 will be in your test set, and 75% of your data will be in your train set. Okay? So yeah, you can change. If you want 80% morally, you can just put 20 here. It will become 80-20 split. If you want 75-25, you can just put this. Then it will be 75-25. Okay. Okay. Now, so what you'll get output? You'll get output as X train, which is your training set, X test, which is your test set, Y train, which is the predicted column of your Y set, and Y test, which is your predicted column of your test set. And what is the shape of it? As you can see, there is this equal split, which is in train, the shape is 1199, in test, which is shape is 400. Okay. Now, you just need to, after this, it's, I mean, just 2 or 3 line of code, you're going to train your model. First thing is you are supposed to initialize your model first, which is decision tree classifier. You're going to use decision tree classifier model. And the thing which I've explained, entropy. So what should be the criteria of selecting the root node? We have mentioned that criteria as entropy specifically, right? And then based on that, we are going to initialize model entropy. And then just use this train and use this Y train. These two parts, Y train have your prediction, X train have your features. Use this and provide that to model entropy and use fit. Right? Use fit is something which will be in all the models. Whatever you're using lossy regression, you're using naive classifier, you're using SVM or any other model. There will be, the function will be same. You just need to change this initialization, right? For loss regression, it will be loss regression, and then you use object.fit for loss regression and provide the same X train and Y train. It will not change. Right? What are the so once you do that, your model will get trained, and your fitted model or the trained model will get stored in model underscore entropy. What are the features it have taken, right? So firstly, let's check out the accuracy of your model. So your accuracy of your model is, the training accuracy of your model is 1, and the testing accuracy of your model is 0.625. How much drop it is? So first, how to find out your prediction? You just need to use the same model dot predict and pass out the test set, and then it will be your predicted values, and you're just comparing through model entropy dot score that how many predictions are correct, how many not. So if you do that in the train set, you have 100% prediction correct, which is 1. But if you do that on the test set, you have, with the same model, you have 0.62. That means point around 737. You are losing that much, 37% of accuracy. What this indicates? I've just explained, I mean, 1 hour back, 1 or 2 hour back. If you have significant biased data, overfitting, absolutely. So it's not, the data is not biased. We are overfitting in this case. So as you can see, we have a big drop between training and test set. Right now, as we established, yes, overfit. As we established that it is overfitting, now we have to do some changes, right? I've explained you, right? We can do hyperparameter tuning. We can do upsampling, downsampling, and we can look for more data also. But in this case, we can do hyperparameter tuning. What we can do is, right now, the depth of the tree is 17. Right? So the tree starts from node, and then the level of the tree is 17. The depth of the tree. It's too much for this data. Right? What we can do is we can trim that, we call it prune. Right? So pruning of depth we can do. Before that, let's check out some more concepts of precision and recall. Right? How many of you understand what is precision, what is recall? Anyone? No? Okay. Let me explain precision recall first. We'll jump on the evaluation metrics. Okay, so precision recall is nothing but sensitivity, and it is true positive rate, or you can say true positive rate. Okay. Now, what is true positive rate? So recall equal to true positive divided by true positive plus false negative. Now, what is true positive? Let's learn that first. Right? True positive is something which is, let's say, in this case, a wine. Actually, the wine belongs to fifth category. Fifth category. And the prediction happens also share that it belongs to fifth category. Right? So actual, let me write this way, actual versus prediction. Right? So actual is fifth category, prediction is fifth category. This is called true positive. Right? So true positive means whatever it is actual that the model have predicted. True positive. True positive. And what is false negative? False negative means, so let's say um, if the actual is 5, if the actual is 5, but the model have not predicted it 5, right? So if, let's say, if the model is let me put it another way. So, let's not take this example because it may confuse you. Let's take two example which is positive and negative. So let's say we have a sentence, right, or a binary classification problem in which you are supposed to predict that the sentence is positive or negative, right? Or let not take this also because you may get confused with true positive and true negative. Let's take you are supposed to predict cat and not cat. These two terms, right? Cat and not cat. Now, if you have if the data is cat and you predict cat, that is true positive, right? This is positive of it. But if the data is cat, right, but you have predicted not cat or non-cat, right, then it is false negative. False negative means it is not negative, it is a cat, but still you have predicted non-cat, which is false. So this is false negative. Now what is recall? Now recall is true positive. So let's say you have 10 prediction. Right? So out of that 10 prediction, if you done true positive with correct prediction, let's say 5, right? 10, and you made false prediction which is 5, right? Or let me change this. Let's say you have done true correct prediction which is 8, and false prediction Fn, false negative, which is 2. Right? Then your true positive, which is 8 plus 10, is going to be 0.8. Right? So 80%. So your recall value is 80%. Right? Which is good. Which is good. Now, if you are supposed to deal with, let me. Did you have any question on this? We'll move for precision, and then I'll explain what is the use of precision recall. Okay, so let's check out with the same example. Let's check out the precision part. So the precision. So precision part is nothing but true positive, same, right? But the only thing which changes here is false positive. Here it was false negative. Here it is false positive. Now I have explained you the false negative. Can you explain me what is false positive? Anyone? What is false positive? Not a cat, but we guess cat. Correct. Absolutely, Abhinav. So if we predicted as cat, but it is not actual cat, so it makes false positive prediction. Right? So that kind of prediction if you're making, then that will be a component in calculating precision. Right? Same formula, same thing. If you have 10 and if your false positive is 2, then your overall precision would be around 80%. Right? Now we understand that precision. What is precision? What is recall? Only this is the difference between precision and recall formula. Right? False positive and false negative. But what actually use of this? What kind of significance or importance it brings in on the table? So let's say if you have, let me give you an example of, let's say you are supposed to build a model for an airport based on let's say uh, feature of personality of a person, or feature of a person, or category of a person, whatever the amount of data you have for a person, you are supposed to change the accuracy of model. That's correct. But Gautam, accuracy of a model you can find out with accuracy, which we have seen that 67%, 91%. But this is different, right? This is going to give you an accuracy, but in a different way. We can use it more than accuracy. So the use case which I'm describing is, let's say, confusion matrix. We are going to it is a part of confusion matrix. I'll show you that after this. But the important part which we are learning here is, so what is the use and what is the benefit you can get from precision and recall. So let's say if you want to build a model for terrorist recognition. Okay, terrorist recognition on air. Let me clear this first. Give me a sec. This. Okay. So the model which we're trying to create here is terrorist classifier. Let's say terrorist classifier, right? And you are supposed to put that model in an airport. Now, if I have to classify terrorist, and if I make a false negative, if I make a false negative decision in classifying a terrorist, how much impact that is going to make? Is it okay to do false negative on a terrorist classifier, or it should not be? Anyone? So false negative for terrorist classifier will be if the person is classified as terrorist, as non-terrorist, but the person is actual terrorist. How much loss I'm going to take by making this false negative decision? Anyone? No? Okay. So what I'm trying to explain here is significant loss. Correct, Anand? What I'm trying to explain here is, for this particular use case, terrorist classifier on airport use case, you need a high recall. You need a very high recall, right? Maybe if you have a million record, and you should have at least 90% or 95% of recall. That means you will have a very low false negative prediction. Right? But if I do a false positive, and now we are talking about precision, if I do a false positive for the same use case, is it a big loss for me? as a country, as an airport authority, as a human being? Gautam, Anand, no, right? Why? Because even if at first glance at my model predict this person as terrorist, then there will be further investigation and there will be further discussion and the further checking of from authorities to check if the person is actually a terrorist or not. But if I do a false negative to that person, that terrorist will pass through the airport and whatever they want to do, they can do it. Right? So it will be a big loss. So in this particular use case, precision, if precision is low, that's fine. I'm good with it. But I should not accept a low recall in this particular use case. Same for healthcare also. So let's say you are creating a cancer classifier model, right? For cancer classifier model also, you should not. Yes, you need a high recall, but not so high precision. So if precision is high, is good, but you should focus on recall more, right? So the decision maker in this particular use case will be recall, not precision, right? Same goes for cancer classifier model also. If it is false negative, then the person may so the people, the authority can capture that person's can identify that person's cancer at first stage, but due to false negative, that person is not treated at time and you know detected that cancer at fourth stage or third stage, and it is we're out of time now, right? So that kind of use cases, you're supposed to focus on recall and not on precision, right? But where you feel that false positive uh, is very important and false negative is not that much important. Let me give you an example of this. This is very important. Why I'm putting so much effort in explaining this is because when you go in interviews or learning for that matter, this will be some of the most frequently asked questions which you'll face in interviews. And if you know it in depth, I think it will benefit you. Now, the use case for precision, when you're supposed to focus on precision, not recall, is you are going to so let's say you based on certain prediction, you are supposed to run a marketing campaign, right, for a bank, for something like that. So marketing campaign cost you per client, right? So you are supposed to make a model. Let me delete this. You are supposed to make a model which is going to predict that which client you should focus on to have more revenue, right? Which client you should focus on to have more revenue. Now in this case, if you have false negative, that means the client which you should focus on for more revenue is not classified as a client for this particular campaign. So you will lose an opportunity, right? That's fine. But if let's say the marketing campaign cost you, right, per client, but if it gives you false positive, what will happen if it gives you false positives? Anyone? So if it gives you false positive, that means it is going to classify a client for this campaign, which is going to cost you some money, right? But because it is false positive, that client is not going to buy anything or not going to convert in any product. So that this cost is going to be is a wastage for you. Yes, high misleading cost, right? So it is going to be wastage for you, and it is going to directly impact on your revenue and marketing expense. So in this case, in this particular scenario, you should focus on false negative. It's okay. It's okay if some false negatives are there. Some people are not classified, which could be your good plight. It's okay, but you should not waste money on the people who are false positive. All right, because ultimately, how marketing campaign analyzes, if you run a campaign for 1,000 people, how many people converted? If the conversion people are very low, that means your marketing campaign is failed. Otherwise, it is good. So let me clear this canvas. I hope you understand about precision recall with these three different use cases. So someone have written confusion matrix. This is confusion matrix. So this is confusion matrix. What is observed and what is predicted, right? So based on that, so if this is observed, and this is predicted, that is true positive. Correct? This part is true positive. Now, if this is observed and this is predicted, that part is false negative. Right? And similarly for other values. And this is again a representation of this same confusion matrix. Right? So confusion matrix is nothing but the representation of observed prediction matrix. Now, the thing which I was explaining earlier, that our model is overfit, right? And we need to do something about that. So what we can do is we can regularize our model or prune our model, which I've explained, that we just trim some leaf. We'll trim some leaf, right? And then so after that, maybe our model will not go into overfit. Right? So we just decrease the depth. Right? So depth limit is 3 now. Earlier it was 17, if you guys remember. Right? Now I have put it 3, and then let's visualize our tree. So this is the same. So this is a distant tree, right? So this is a distant tree which our decision model have created. So how it is making decision? This is the root node right now. It is making decision based on alcohol. If alcohol is less than 10.25, it's true. Left side, if false. Right side, the right side have good quality wines. The left side have bad quality wines. As you guys remember that I've said, alcohol is having a good positive correlation with the quality of wine, right? As you can see here also, if alcohol is more, the quality of wine will be better. If alcohol is less, the quality of wine will be bad. Right? Similarly for sulfate, for total sulfur dioxide. So if you want to represent this to your client, okay, so your wine is, so what are the best recipe? What are the best component of a good wine? The best component of good wine is, let's go to this side. Right? Good wine is alcohol should be greater than 10.5. All right, and after that, the sulfate is so in this alcohol should be greater than 11.45, and sulfate should be greater than 0.695. And after that, with the combination of these two, we are going to get best quality wine, which is class 7. And based on, and obviously if it is less than that, then it is class 6. It's class 6, and then if it is comes in this category, this is class 5, bad quality wine. So we are able to understand that, okay, the two main components of having a good quality wine is alcohol and sulfate. Right. So as you can see, we have better accuracy now. We have we do not have better accuracy, but we are not overfitting our model now. So our test accuracy is 0.975, and our train accuracy is 0.605, which is significant, which is a small degrade. That's not a big degrade, so that doesn't matter. So our accuracy, which I will consider, is 0.60, right, for us, or 0.959 for us for this particular use case. All right. Apart from that, I'm going to share this with you. I think we just have accuracy, and apart from that, we do not have anything else. This is this precision recall and F1 score. Okay, so F1 score is one thing which I should explain. Give me a sec. Let's go back to, before we end this session, let's go back to, so we have precision, we have recall, but we do not have a quantifiable value which we can focus on, which take both weight of precision and recall. So for that, to solve that problem, we have F1 score. So F1 score is consists of precision and recall, and sum of precision recall, right? So this is nothing but harmonic mean. This is nothing but harmonic mean of precision recall. So it's going to give you some value which is going to range from 0 to 1. The higher it is, the better it is. Right? So if it is 0.8 or 0.9, and that means you have good model which consider both precision recall. Right? So we have reached end of our session today. Tomorrow we are going to cover unsupervised learning, K-means algorithm. We are going to cover NLP-based tasks. We are going to cover some of basics of image processing also, and we're going to scratch some surface on deep learning. So if you guys have any question, feel free to ask now. Otherwise, we'll call it off for the day. Anyone? No? Okay, if not, then I will call off for the day, and thank you everyone. Thank you for your time. Thank you, Murli. Thank you everyone else also. I hope you must have learned something today. I tried my best to explain the insight which I have, the little knowledge I have, and we'll meet tomorrow. Okay. Thank you, Ritika. Ritika, you can take it up from this.
Okay, thank you.
You want to add something
Hi
on this?
everyone. I hope like you will find the session excellent, but we need your valuable feedback. Kindly mention your feedback in the chat section. Am I audible to you all? Kindly mention your feedback in the chat section. Okay. From Muralidharan, it's really good. Next, Gautam Krishna, it was awesome. That's really great. Next, Akash, very good.
So, guys, you are supposed to do that on private chat, not on public chat. I am able to see that. Okay.
Okay.
Okay,
So,
guys, I'm taking off. We'll meet tomorrow morning.
okay,
Bye.
in short, session was awesome. So that's pretty good. So we will meet you by tomorrow, same time, 10 a.m. So be there and just attend the class. Okay, thank you very much. Bye. Have a nice day.